smells just like like roadkill. Oh, hey YouTube. Hey, we didn't see you guys there. We were not talking about you at all. We didn't say anything about YouTubers. There's nothing. No, I didn't say anything. I said nothing. It's fine. And you guys are here. It's great. It's great. We're having a good time. All right. What else? What else do I need to set up to be streamer boy? I don't think much else. So we're gonna get started pretty soon. Because I need to clean off the desk a little bit, maybe just a little bit, because like I don't fit. There's no room to do a project. What is this? We need to clean some of this stuff off, and then I need to begin work on the circuit board that we designed on this stream. A gaming chair and gamer sups. I'm sitting at a standing desk, so it's about 30 inches tall. I don't know what the metric is on that. I'm not good at that conversion. What's it like? 1 hogshead? But yeah, I'm at a standing desk, so the stools are a lot taller. If I were to get a gaming chair, I would have to get a new piston for it that's tall enough to be at a standing desk, which you can do, by the way. A lot of these desk chairs are modular. You can buy the different parts for it. So if you, like me, are an indomitable fat person, I gotta watch the cursing at the beginning of streams. If you are an indomitably fat load like I am, if you get those rollerblade wheels, those aren't 2 wheels distributing all the force evenly where the chair leg is. It's 1 wheel that's offset, and so it'll actually bend your typical base, your typical office desk base. And if you're on flat floors that are not carpeted, those rollerblade wheels are really awesome because you can just scoot from thing to thing. You just push off, and it's like a zero gravity simulation. But if you're having trouble with those wheels bending like that for your office chair, like because you're over 200 American pounds, you can get a solid steel. It's like a hollow steel base that's like super duper strong. I don't have them anymore, but yeah, Ninja Social works for Linux. That's really good to know. Dev, you were the one that turned me on to this program, right? It's pretty easy to use. It's nice. Although I fear that it is Chromium, and so I'm adding Chromium stuff to my whole ensemble. But this has been pretty good at just like fusioning the 2 streaming services together. I don't think I'm gonna add Kick to my ensemble, but I could if I wanted to. Insta Live, I could go live on Facebook. I think I still have an actual account there. Rumble, Arena, PTube. What the fuck? Okay, well anyway, yeah, we're just doing Twitch and YouTube right now. YouTube Shorts should have been its own application. It should have been separate from all of those. Don't know if it was you, OBS. Okay, sorry. I forget who shows me these tools. People are so nice. And they go, Bother, you should use this program. It's really good. And I go, okay. And then I use it. And I'm like, actually, that is really good. I should give everybody credit that I possibly can. But yeah. I always check the stats. Shipped big and tall on a business furniture site. Yeah, so the base that I got was awesome. But then Steelcase was having a huge sale on Amazon, and I bought one of their chairs, and it totally ruined me because it's actually a really good chair, just straight out of the box. I haven't had to do any modifications to it. But a lot of these chairs you can just like modify. People throw out a whole chair that just has like a bad piston. You just have to buy a new piston, and you get your big ball peen hammer or your flat, what is it called? A dead blow hammer. There we go. You get your big dead blow hammer and you just wail on it for like 25 minutes, and eventually that piston will fall out. So yeah. Put a new one in there, and you've got like a brand new chair that somebody's already farted into. Now I'm small enough I fit within standards. I'm working on it. I'm working on that. Where's the? Oh, there it is. Yeah, there's still a little excess going on, but my glucose level control is amazing. That's been the main thing that the GLP-1s have brought back to the table. I have been on GLP-1s like 10 years ago, literally 10 years ago. They've been around for a while. And I was on the Eli Lilly one, Victoza, and that one puts your stomach in a knot, which I didn't mind that much. It just was kind of uncomfortable. And so I eventually stopped taking it, and my weight came to be a problem again, and my insulin resistance came to be a big problem. And so they put me on Ozempic, which is funded by the UPenn hospital system, their giant mega conglomerate UPenn hospital system. They just text me and send me these things, and then my doctor writes reports about it that end up feeding into the statistics of the giant pharmaceutical machine. But on those drugs, it's much less of like a side effect kind of fight with the newer ones, the ones that are super popular now that everybody thinks everybody else is on. My glucose control is amazing. I'm not eating big meals. That's one good thing about, the glucose control is not so much a direct result of the drugs, although some of it is. It's a lot of very subtle effects. The main thing is the psychological damping down of hunger. And so eventually, I think I'm going to get there, but I'm taking it easy. I want to be easy with my liver, Blindness as a side effect of, that's because, no. Okay, yeah, as a side effect, people are rapidly losing weight, which is incredibly dangerous. All these people should not be so rapidly losing weight. If the medication was less expensive, people could take their damn time, because what happens is when you lose a ton of weight, that can end up having deleterious effects on other parts of your body. And so detaching retina are a danger. So that can cause blindness. I'm not losing weight rapidly, so I'm not going to be suffering those effects. But yeah, that's apparently blindness can occur under rapid weight loss. So that's sort of the lawsuit going on, is that it wasn't listed, as a viable side effect. It's a side effect of losing weight, and they don't know if you're going to lose weight when you take the drug. You sort of lose an initial bolus of weight, and then beyond that is depending on what you do to your habits after that, I guess. Yeah, but it's not a thing if you don't lose 60 pounds in a month, right? That's my understanding of what that lawsuit is, and I could be getting all of this wrong. So I'm not a lawyer. I just play one on TV. New soldering iron tips. I'm excited about some of these. Let's just start. Let's just start. No more start soon. Nobody knows what start soon means. Nobody knows. It's been lost to the annals of time what starting soon even means in the context of a stream where I'm not working on a project. I'm talking about my weight instead of actually doing science and technology. Why would then there be a start soon sign up on the stream? This doesn't make any sense to my primitive brain. It's too smooth to understand that not working on the project is starting soon. Anyway, we've started. I can stop complaining about super minor things. Hi everybody. How you been? How's your weekend? I haven't been streaming. I didn't hit Saturday. I meant to stream Saturday, but I've ordered a ton of parts. I ordered knobs. Bask in my knobs, chat. I don't have them out right now, but I would be showing you my knobs with wanton disregard for standards and practices and morality on the internet, which is what Twitch used to be. Just without the knobs, you weren't actually allowed to do that. But Twitch used to be very internet-y and very unplugged, and it was awesome. That was the old days of Twitch. I miss those because when they started monetization, things were as halcyon days. It was oh, we can directly support these artists. And well, now we have ads, and I promise you that while ads are running, I won't be doing anything during the ads. So I'm gonna have to take pauses in the middle of what I was doing, and we will just talk about random stuff. Hopefully I've got anything to talk about, being that I'm a severely boring person. No, it's fine, but we'll talk about whatever when there's an ad block going on. And for those of you that don't run the special, you should look it up on GitHub, plugin to move the ads to the small window. And if my stream is getting moved to the tiny little window on the side, you'll see in big green text, ad break. The ad breaks are 3 minutes long. I still have to set up a timer to show everybody how long they are. And according to my tools, we got about 30 minutes for the next one. So, all right, so where am I? I ordered a whole bunch of parts, and I got one of the two big packages that I was expecting, as well as the one from China. And the China one is directly from Seed Studio, and we got 10 powered MULT boards. This circuit, in my mind, is simple enough that I am confident in getting 10 boards all at the same time. I believe in my heart of hearts that this design will work. Now we're going to put that to the test today. I'm going to try to build this thing and try to put it together. If it works, then we're good, and I've saved myself another $75 order. $75? I thought it was $10 for 10 boards. Yeah, $10 for 10 boards, $20 shipping, $20 tariff. I spent $40 on tariffs for all these parts. Ridiculous. Time to try. I am training AI. I'm happy for the parentheses. He's tried that for. So you get the ADHD drugs can also have weight loss. Huh? Okay. Anyway, so we're building up the board that we designed the other day, which is the powered multi. I put a little bit of work into that. I mean, it was probably like what, 2 streams of design to do that. So it's been like a 10-hour board. And for $70, $60, $70, it's pretty good to get 10 boards of this quality. I was kind of shocked that we could do it for $50. What was it? About a year, 2 years ago? I wonder what happened. Why all these tariffs and ramping up expenses? Weird. This is why we haven't done circuit boards in a little while, because this sucks. Even if I got it from an American supplier, their prices are going to be because everything else is. So, God, it sucks. You people overseas have it good. You can just open up your program and design it, and you can get like $5. You can wait a couple months for shipping, however long that takes. Damn. Anyway, I've spent too much in tariffs. Stop ordering stuff. The whole point of them is to steer us towards American companies. And while there are American companies that can prevent us from spending on tariffs, I don't know. I like Seed Studios' design, man. They just, they're good boards. The Osh Park allows me to go too small, and their boards are good. Osh Park is perfectly fine. Maybe we should order from them next time. I don't know. Probably should. But anyway, what we're doing now is the second part of the design process. The first part of the design process is that you have a good idea. The second part is that you make a circuit out of your good idea. The third part, okay, maybe we're not on the second part. Third part of the idea is that you build it on solderless breadboard. The fourth part of the idea used to be that you would build the idea on perforated prototyping board. That's not the case anymore, although it might be with tariffs, to be honest. Nowadays, $5 for 5 circuit boards is insane. You would be crazy to try to build your circuit on a perforated prototyping board to test it first. Instead, you jump right to the PCB and assemble it. That's not necessarily true. It's way better to do the perforated prototyping board if you want to see how your design functions in a scenario where doing this won't completely ruin the circuit. Solderless breadboards can be pretty unreliable, and the new resistors, the only ones we're able to get, which is the 1% resistors with the very, very tiny leads, like 1/8 of a watt or something, these do not make good contact with the springs inside of the solderless breadboard. So, going to perforated prototyping board, it's a good idea. You don't really have to do it necessarily. You can go right, if you're comfortable with your parts in CAD and you're comfortable with your CAD software, you can boom, boom, boom. You can create a PCB really quick. You could just skip that other step if you're okay iterating over the course of a week. One thing is, if you build it with a perforated or with a solderless breadboard, perforated prototyping board, your design is in front of you. You can make corrections to it. If you get it on the PCB, you are iterating, much like with 3D printing. You have to wait for any of your issues. And because of that, because of the manufacturing cost of time being the most precious resource, what you do is you get that initial PCB working no matter what. No matter what, we have to get this working. We have to get this PCB, the one that I'm holding in my hands, or an iteration very close to it, working before we go on to the second order. And then we can actually, design everything out. How's it going, Mahalo? Nice follow-up with the tariffs is that the Japanese yen is crashing and the U.S. central bank is using billions to try to prop it up. I've read that headline. I have an American PCBA right now in my backyard. That must be nice. It's still cheaper to buy from overseas, even because I spent $40 on tariffs for both the parts and the PCBs. The other thing is that I'm building a bunch of eurorack modules, and these eurorack modules are designed well before this day and age. where sort of our global village is collapsed. So these are requiring me to buy weird boutique parts, and those weird boutique parts are coming from overseas. So that's the other $20 in tariffs that I had to pay this week. And I got to pay off my credit card. I got to register my car. I've got all these like government expenses that I need to do. Man, calling credit card debt a government expense was a subtle. Anyway, how's everybody doing? We're gonna start building here, and so I've got all of my like stuff out. I've got all these surface mount parts. I've got bins full of things, headers, capacitors. We're not gonna need much for the powered multi. A powered multi is a fairly simple circuit. Does anyone making something like perf board for SMD? Yeah, mini circuits. They're here. Hold on. One sec. Let me lean over here without spilling my drink. There we go. All kind of stuff exists to help you with that. Here, check it out. There are, and it's not necessarily for mini circuits, but you can get these all over the place now on like all over Amazon and stuff. Just breakout boards for surface mount. So if you had an SOT23 part, you could solder it down to this, solder a couple headers on there, and then it goes right on to the breadboard, the solderless breadboard. Like you know, we've used all kinds of iterations of this stuff for some of our circuit testing. Okay, so we're building my powered MULT, and this is a design from last week. Well, the other week, and it's basically one-for-one replication of the input to the output. So what that looks like in a schematic, there it is. Looks like this. So common engineer parlance and schematic drawing, we have our operational amplifier, and this operational amplifier has a certain amount of gain to it. When we feed the output back into the input, it cancels out that amplification and we can control it. So what we have is we have R1, a feedback resistor. C1, what is that doing in there? It's a feedback capacitor. Well, how do capacitors operate? At higher frequencies, the capacitor will be letting that voltage through and then canceling out the higher frequency. So C1 is in there just to damp stuff above the level of audio in it so we don't wibble away and explode. R3, don't know. I don't know. It does something. It's kind of an interesting thing. I think that needs to be a 1 kilo ohm. And R1 and R2 in a non-inverting operational amplifier, since we only have 4 of them and we need to do an, we only have 4 of them per chip and only 2 chips are really going to fit on this thing. So our powered MULT is going to be a 1 to 3 or 1 to 6. So there's 2 inputs, and if you don't use one of the inputs, we are routing the signal into the other input. If you use both of them, it's 2 1 to 3s. If you use one, it's 1 to 6. So you're missing a source based on sound canceling device? What are you guys talking about? Wait, huh? No. Okay, so if we pipe audio into here, the audio goes into the non-inverting input and comes out the output uninverted, but we're feeding it back in to the inverting input so that it cancels out the, like 300 gain of the bare op amp. That's what we're doing. That's why we're feeding it back into itself. Now, in terms of like impedance and boosting the signal, we are following a design from a paper. Where is that? Somewhere around here, there's a paper about boosting getting the op amp to be able to drive audio or whatever signal input quickly. It was like a triple E. It was one of those engineering magazines. Hold on, let me see if we can pull that up. Yeah, that's the NLC filter. These are the modules that I'm building that already have designs. What was it? It was I really just want you to look into my history, sir. powered multi. Oh God. Powered MULT Euro rack design op amp. The buffer, building a DIY buffered multiple from N8. Which op amp for a buffered mult? TL074. That's not the circuit we're doing. There was a lot of, well, there's something about stabilization capacitors. And there's the 1K out in front. So yeah, we're gonna do 100 kilo ohms for both of those resistors, and then the one out front is a 1K. Yes, let's look at your history. I don't know, you know, other streamers don't do this, and they, you know, maybe it's funny to get in trouble for like looking at porn, because we all look at porn. But I started a new computer to stream from. This is a completely brand new computer in my whole setup of computers. So I have absolutely nothing to fear from history of browsers coming up on this computer. There's just nothing. So, and you know, more streamers need to do this. 3-letter gangs don't want to look at my history. I don't know. I think I did have them look at my history at one point of browsing on a work computer. 33PF here. I've seen other values for like mutable instrument circuits. If we look up, what is it? Mutable instruments, Veils maybe. Was it Veils? Similar with a 1.0 M, but I don't know what's going on there. That's a little weird. I think that is inverting, and that's for an LED anyway. 100 picofarad. I go to the mutable instruments designs because Emily Gillette is a genius and has created some really quite amazing circuits. And they're all available for free under like MIT license or something. What is it though? CC by SA. What is all the, wait, what are you correcting, local admin? Oh, it was she, because Emily Gillette. HR. Oh, that's a different. The amount of times I've had to be in the room with HR because of this. Construction is rough. What's going on? This is not sound compression. We're not compressing anything. We are a multi. When you plug like a signal from eurorack synthesizer into multiple things, again, MULT, when you plug your signal and you split it in two, you're taking half of the current and putting it into both directions. And apparently, given the very minuscule amounts of current that we're using in order to define voltage levels in a eurorack synthesizer, this is a bad thing because you can actually affect, with the capacitance and the lines and stuff, you can affect the signal, right? And so it helps to have a multi that will split the signal without draining it, and then also give it a little bit of oomph behind it as it sends it out in the various directions, in the way that you would give it the same amount of oomph if you're just coming out of a normal synthesizer module, just to make sure. Yeah, this is essentially a splitter, but it's a powered splitter so that you can split a lot without splitting your signal. Yeah, that makes sense. So I love this. I tried to do it, but it made everything quiet. I had an unpowered MULT, and Julian was complaining about it. So Julian is my buddy who does synthesizer stuff since we were teenagers. And I have been on the hook to build him a synthesizer for eons. So one thing Emily does is pulls in voltage reference sources, and this can help you bump a 3-volt signal up, or just basically I don't know, divvy out your signal but like 1 to 1.6B. I don't know what's going on there. These are also inverting. You can see because the positive goes to ground, that means it's an inverting amplifier. If you got a lot of amplifiers, inverting it helps you realize a lot of different gains. If you don't invert it, the gain is 1 plus, and then whatever the equation is of your resistors. In our case, it's going to be 100 over 100, so it's going to be 1. So 1 plus 1. Does that mean we get a 2 gain? Does that mean I need to do something differently in my circuit? I need to find my sources on this stuff. Hold on a second, wait a minute. Or do we need one of them to be like nothing? That ain't right. Hold on. Powered multi. Start dockage when powered. Powered multi eurorack design op amp. That's what I was looking at before, but that doesn't work. Powered multi design. Multi-voltage SoC, multi-brand, multi-trade, Euro rack. Maybe we did want the N8 link. Active buffered mult is a great first project. Hey! So they're not using that super duper feedback one, and they're using all of the op amps. We saved one of the op amps so that we could put LEDs on ours, because I want to have LEDs on ours because it's cool. So their design is a little bit different. So we're not doing the N8. Part 25, buffered mult. Built my first active multiple eurorack PCB, mini modular. Let's see, what do we got? Like, there was a synth guru, maybe? No, or a stack exchange. Was it a? My research. I don't remember what my research was, but you know what? It'll be in the Discord. It'll be in the Discord. Let me just rewind the Discord a little bit here on my stream projects, because I typically put this kind of stuff specifically in my stream projects, which is why that is the only channel that I will actually kind of moderate periodically, because I want to be able to pull this stuff up so that I'm not completely put out by doing what I'm doing right now, which is flailing, trying to explain myself to you guys from things that I've decided eons ago. So yeah, this is a circuit that was tested on the page that I was looking at, DIY synth from Reddit, but that's not the one that I ended up going with. So where was I talking about that? Synth DIY. I guess the links must be in here. Oh, do I hate you now? Oh, do I hate you now? Can we do like VX Reddit or something? No, still wants me to log in. I don't really want to log in right now. All right, I'm not going to log in on my stream. Yeah, it's just one of those things. Eurorack tariffs just went up 5%. God, they are just so, it's so random. Guru Gara? Nope, that's selling me a product. They're not going to give me a tech specs, etc. There's a link to some professional like EE Times or something like that, and I guess I didn't link it in the Discord, but they go over what this circuit design is. I'm going to Micro Center today. Check out the water cooling section. They've got all of those fittings that I need. I need to turn the whole water cooling PC 90 degrees and add a giant reservoir to it. I'm getting sick of doing these constant refills because I've got like an area that forms a bubble, and the tubing that I'm using, I guess, lets air in. The silicon rubber tubing has some kind of a tendency to let air in, which is crazy. Yeah, different design, and I'm just looking for it's like driving a signal with an operational amplifier, and then it goes over what all the funny bits are on the thing, and I probably could get there in a couple clicks if I had my Reddit logged in. You want me to send you some 90s? No, I'm good. I'm good. Alibaba's probably a little better for getting those things. Micro Center in a pinch if you can drive to one, but does it let water out? No, because what it does is it displaces the water, and then the water in this like boom tube that I made with an opening on the top and the power supply sitting right below it, it'll let water into that, and then that can actually tend to drip into the open grating of the power supply. My water-cooled PC is very weird looking. It's hard for me to describe. I would have to show it to you. Yeah, so I can't get into any of these unless I take a look at, can I look at like the cache? Reddit is an American social media that man, as much as I would like to visit, show me the cache. I miss those days on Google. Looks like I just don't have the option to somehow get there without having a login. I could jump over to the other computer, but the point is, what is it? Driving. There we go. Compensation techniques for driving capacitance load. It's an EE Times article. And it seems like a lot of these module makers have followed this design. So there's a couple different things going on here. We've got a high capacitance and obviously a resistance load sitting on the end of the op amp. So CL and RL are the load. And then we have an R ISO. So what does that do? R ISO is voltage feedback amplifier, which is slew rate of 460 to small signal frequency, various values. See from the graph, minimum value R ISO is 10. And we're going to use 1K there. But what is R ISO doing? High-speed amplified driving the inputs of an analog to digital converter, ADC. The amplifier's settling time and bandwidth might undergo degradation as the ADC often has capacitance present at its inputs. And you get capacitance when you plug in wires and cables to stuff, right? Try archive? No, this is fine. This is fine. We got it. So, amplifier must preserve its setting time and bandwidth performance so that the recommended value of R ISO will optimize the op amp's response. So this is a unity feedback fart. What's up, Demi? How's it going? I've got to convince myself that I've built the right circuit. Just because my previous explanation was crap, I have to make sure that my head is in the game and we choose good values for all this stuff. So 345 megahertz rail-to-rail output voltage feedback, slew rate of blah, blah, blah. Figure 2 shows, okay, so we got our rates here. As you can see from the graph, no, I absolutely have not looked at the graph. The minimum value of our ISO is 10. Both bandwidth is peaking increase, blah, blah, blah. One of the cool things that I've seen going on, well, actually, you know what? I'll talk about that in 7 minutes. All right, unlike the out-of-loop compensation technique, wait, hold on. 30 drops, so we're not peaking as we start moving down with our voltage level. That'll prevent noise. Technique, blah, blah, blah. When driving a large capacitive load, an isolation resistor, R ISO, should be connected in series between the op amp output and the capacitive load to provide isolation and to avoid oscillation. Isolation and oscillation. They're not two sides of a coin. They're two totally different things. But isolate in order to not oscillate. Proof is in the pudding. Just plug it in and see if the smoke starts to emerge. We'll get there. Yeah, we'll get there. And I have a couple more things that I need to explain. But yeah, so avoiding oscillation, that's what R ISO is doing. And CF is also damping high frequency oscillations. RG and RF are our tuning of the gain. Etc., etc. Bandwidth decrease. Okay, therefore, op amp, 1000 PF, capacitive load, bandwidth will be reduced. Okay, so that's sort of why this design is put this way. It's a non-inverting op amp. We've got this feedback capacitor. We've got an isolating 1 kilo ohm resistor. RG and RF are part of our transfer functions. So common, or top 10 amplifier designs. Oh, this is gonna do other stuff. Top 10 operational amplifier. Fundamental operational amplifier circuits. This is a pretty good one about electronics, Arrow, I guess. Voltage follower, inverting op amp, non-inverting op amp. So our transfer function for the inverting op amp is Vs is equal to negative VE R2 over R1. So R2 and R1, it's just dividing the two because R2 is coming back in here and canceling whatever signal is present. The non-inverting op amp has VE, because remember it's non-inverting, there's no negative in front of it, 1 plus R1 over R2. So what happens is if R2 and R1 are the same value, value over value is equal to 1, and then it becomes VE times 2. So I don't know if I need to do something in order to make that not multiplied by 2. How would I make 1 plus R1 over R2? Is just leave out a resistance? That makes it infinite. If I just short it to ground, that doesn't make any sense. I don't think that would do anything good for our circuit. So I need to see what values I need to put in here in order to make a non-inverting op amp unity gain, and then put eurorack at the end. I haven't chosen values for any of this stuff. This is part of the design that I just kind of skipped over. Boy, would I love to be able to see in there. Oh wait, but I've got, well, those aren't non-inverting. Those are inverting, the ones that I took. There's basic electronic tutorials. 1 plus RVRF. Voltage follower, unity gain. You would use, do I need to put a 0 ohm? That seems a little weird. Shorting to ground, that sounds like a great solution to circuits. Yeah, we can just go back to campfires. I know, every time I say R2, it's R2. So it's a robot. What do you guys, but man, you guys talk about everything. Unity gain non-inverting buffer options. Validating browser. Nobody's going to give me a good one, huh? Dual op amp footprints. It seems like most of what I get would be from that Reddit post, which is what these are. That's what this is. But they were going into inverting. Were they? No, not inverting. But it's just connected, and then it's got the 1K buffer. If I also have a capacitor across that, that doesn't do anything. That seems a little weird. I feel a little weird with that. If I just put like a 0 ohm resistor on it. Oh, there's a 100K to ground on the input. There's only one. Just ask the AI to train you. I mean, I guess we can put it together with these values and see how it performs. I just got in the mail TL074s, so we luckily we have plenty of these chips to use or blow up. I don't think it'll blow it up. I think having R1 be 0 makes it so that's 0 over something, and then it cancels out the 1 plus, so that we have just, oh, we're in the middle of an ad. Oh no, an ad starts in a minute. So I guess I'm gonna have to put a 0 ohm in there and then ignore, well, the resistor to R2, the resistor to ground is also just not in there. Where was the circuit that we were looking at? Our ISO is 0, CF is 10 PF. Because I think the Emily Gillette circuits did 20p. These are 33, they got a 100K there. It's a 100-100. Is that unity gain, or is that going to be a 2-to-1? Capacitor becomes the not unique. Okay, where are they talking about? Familiar inverting op amp circuit. Oh, never mind. With a gain of -1. So I need unity gain. I would get double if I did 100-100. So my circuit is actually wrong. Yeah, see, the capacitors and the weird circuit design is to tamp down stuff like this happening with the signal. So these are inverting, so they're not valid for what I'm looking for. I don't know if we have a Gillette design that does non-inverting sort of newer high capacitance load designs like this. We have the paper to back us up on this. we can choose our values. I can put a 0 ohm resistor in one of the slots, and then the other one I can have a 100K to ground from... Can I actually do that from positive? I can't. And we're in an ad. All right, so we got a 2-minute ad here, and I was talking about approximately up. Have you guys seen a couple of the streamers playing approximately up? All the stuff that we're talking about with amplifiers can actually apply to that game. You can have it so that you move a lever and it will move to a particular height with your device, because you can actually check your distance to the ground and then have your input height error to whatever your perceived height is, and you send that into a proportional, you have a proportional control on that will then guide the thrust of the rockets of your device. And you know, you can plug that into numbers all you want, but it would be really cool. And if I had the time to do this, and I've been meaning to, is grab that game. Oh, I do have 100 ohm to ground on that thing, kind of. It's going into the LED though, in kind of a weird way. Anyway, that game would be a really good lesson in proportional, integral, and derivative control systems, because all the math functions exist in there, and all of your controls are either -1 to +1 or 0 to 1. It's a lot like eurorack with 10 volts. It's negative, positive 10 volts are sort of your playground, but you can have 0 to 5 volts, you can have 0 to 10 volts, you can have -10 to +10, -5, +5, 8 volts. It's like all kinds of different weird things can happen inside of eurorack. Same thing goes for approximately up, and all of your designs don't have to actually be human controlled, although they can be. You can do a lot of the, and I would be fascinated to do PID control and actually sort of, I don't know, reinforce the lesson of why we damp the different elements of that control system. It would be kind of really cool to explore, because you can start out with just like a platform and a lever. You move that around, you go, oh, that's fun. And then you can do the distance sensor. You have to do some missions in order to get it. The distance to ground sensor as your error percentage, and see how that goes, and if it oscillates, and kind of tune the feedback into the amplifier in order to damp the control system. And then you put in the proportional and the integral derivatives, whatever that stuff is, all that weird math that'll make it go shoomp and just stop at the right height. I think that would be really fun to do. We got about 30 seconds left. 30 seconds in the ad left. I think this was based on the Emily Gillette design. Oh yeah, I can close that. And then I have to wait for my little light to blink at me. That should give me just a slight delay. A slight delay from when the ad break is done. That seemed like it was instant. I don't know if it's actually waiting the amount of time that I wanted it to. Welcome back, everybody. How's it going? So what I have in Node Red is the ad break begins. We set a duration to turn the whatever it is, the ad break text off. We convert milliseconds to seconds. Then I add time in seconds. So I'm taking message.delay times 1,000, and I'm setting that to the value of message.delay. So I'm overwriting that. And now message.delay is in seconds. So then I add 10 seconds to message.delay. And I set it as message delay. That's not working. That for some reason, this part of this is not working. But then override delay with message.delay. So delay is equal to message.delay in seconds. And then it sets off my green light for 2 seconds. That was not 10 seconds afterwards. To the value JSON message.delay to the value JSON message.delay. All right, so something here is not adding 10 seconds. I don't know if maybe we're not necessarily in seconds at this point. But it's times 1,000. So delay times 1,000 would make it, oh, times 1,000. Wait a minute. that's turning it into milliseconds. So 10,000. Yeah, it's not, it's seconds to milliseconds. Add time in milliseconds. Okay, so now I've got a 10-second delay after the ad break ends. Wait. Ad break begin. Well, wait a minute. Whoa. Oh, I'm adding the time in the wrong place. Yeah, I need to add another delay, like manually. So yeah, this goes back here, and here I need to do another delay block. And this one's going to be 8 seconds. I did it wrong. I thought I would add to the number and that would do something, but I'm trying to glom onto this right here. So editing it beforehand is not gonna, that'll delay everything and I don't want that. Oops, what's going on? Because the ad break in progress will go away and then my light will flash at me. How can this be so complicated? My Node Red, it does a lot of stuff. It does a lot of like things that warn me of things that go on in the stream. Even activating an overlay needs, I should probably make like a subroutine for this because it has to actually get like a number of the scene. And so I automated it getting the number of the scene because it's annoying when you move stuff around in OBS for it to reassign the number and break all of your stuff. As usual, this is just because I've scrapped together these tools and they're not professional. I've done the job of many different people who would, you know, generally be on top of things, and I'm not on top of things. So TLV 840, I think it might be magic. I don't even know what that is. TLV 840, never heard of it. Suggested reading on stabilization caps. They're there to help overshoot. And then I was looking at Veils. Veils has a particular circuit on its LEDs. That would be this here. It's got a 1M going to ground, and then it's got a 1.2 going to ground, and the LED doing weird stuff. It's a weird circuit. I took this design, and I have two resistors here. One's going to ground, one's coming from the input. I don't know what the ratio of those are, but I know that R10 is the one that would then go to ground for biasing the LEDs. This avoids a little dead spot in the middle on your LED circuit. So I don't know where I got this design from. I don't know where I got it from. I probably should have put some values in there, but avoiding that little dead spot is a good thing. So I think maybe, now this is a different circuit. I don't know which Mutable Instruments I got this from. I probably need to pull up that Reddit thread in order to figure out what all our values are. We also have an order of operations issue. So I haven't even gotten to the build yet. This should have been easy. But the order of operations issue comes from, well, let's just look at the 3D model and I'll tell you. So we go over to our two-dimensional model. And this, by the way, this is a fixed design now. This is representative of what is on the actual circuit itself. But if I go to the three-dimensional design, we can see what some of the flaws are in the design of this module that I can't avoid. I cannot avoid. So look, it's powered MULT. Couldn't be any more simple, except dun dun dun. We've got all of these conflicting things on different layers, and these ICs appear to have a hole punched in them. The hole punched in the IC is something that we will have to deal with. I cannot solder the IC in until I install the jack, and the jacks take up the entire thing. I made this two horizontal panels wide, and I decided to stick with that. It comes with a lot of challenge. Not only that, but if I install the jack, how do I install the decoupling capacitors? The LED, these I could get to, but I wouldn't be able to get to these. So we need to, number one is install the power plug, flatten it out with the flush cutters. Number two is install these two jacks here and here, flatten them with the flush cutters. Then install these capacitors. I mean, I could do these first too. And then nobody gets flush cut after that. Then I can install all the rest of the electronics and the jacks, and then we're done. So that's our order of operations today. Totally not confusing at all. I don't know. Well, do I want to do the... I have to do the through hole thing, but I don't have to do it until I do the rest of the jacks. Yeah, I can do just the jacks that have ICs over them first. So first things first, my people come first. Let me install these capacitors and LEDs. That's our first thing. And I just got my order from Pace Electronics. I've got a couple new tips here. This one is pretty similar to the one that we were using. I think it's a little longer. Yeah, it's a little bit more extendy. No, it's actually the same thing. So it's just an extra one. I already have extras of this one. Oh well, then we got more of it. It is the one that I like to use, and I'll probably use this one today. I got two of the super duper powered ones. These look like a slightly different design from the old one. Wait a minute. No, maybe they're not. Maybe I just used the crap out of this one and it died. This is a dead iron tip. This one does not work. I have two more of these now. These were all like about $20 each, so this is a $100 order. There's number two. They got like a shiny ring around the top that this one doesn't have. That's new. I wonder what that's about. And then I got something fun, which is this odd-looking chisel. Probably for like super duper high temperature stuff, or just like, you know, big pads. I don't know. Yeah, they're clean for now. The clean is not good though. And then I finally got a wedge tip. We could finally show off proper Pace soldering iron drag soldering. I can't believe I have to put a 0 ohm resistor in one of those slots. We'll look that up a little bit more later, but I think some of these tips people sell are dirty metal. Well, these come directly from Pace, so I think this is going to be a good iron tip for the... Well, actually, you know what? We're going to need the needle tip for some of this. Yeah, we'll start with the needle tip. That's probably better for this. These circuit boards are like... The features on them are so small. When you design stuff to the bleeding edge in a professional CAD program, it tends to be shocking how small things are when you get them in the mail. Story of my life. Ha ha ha, penis joke. All right, anyway. This has got to change. Something here's got to give. We got to start putting stuff away. Give me one sec here. This is the result of me building off air. I didn't get to a lot of building off air, actually, to be honest. But I did do enough to get the desk to be completely disheveled. So we're going to make some room for an actual soldering setup, and we'll hump the microscope for this one. These books are not going to sit flat. Pits in the tips. That sounds awful. No, this goes over here, but we're going to need that soon. This can go down here with the surface mount parts. This is over here. Got my solder ready to go. I have one jack there, but I got the bin full of jacks. These are boards that we're going to work on once we finish the MULT. The MULT's kind of important. We've been working on that one for a bit. I'll put these over here. Switches. We don't need those. Oh, this one also has some knobs in it, but not the good ones that I'm trying to use. Caps. I got a new thing of caps. You're supposed to start cleaning and make a mess during the stream to be a pro streamer. Well, it's kind of what we're doing. It's more or less the name of the game. That's the name of the game. So the capacitor choice and the resistor choices we're going to have to get to the bottom of. I may have to do that on my other machine in order to access Reddit so I can read that thread from the DIY synth people, which is really pretty annoying. All right, we need LEDs and we need 0.1 microfarad capacitors. I've used up a lot of my 0.1s. I think in order to get 0.1s of the right size, we got to go to this book, which is a capacitor sample book, and it's running out. I think this one has no, yeah, 100 NF, it's gone. Where did I get my, are these, wait, these are 0603, 50 volt, 105K. These are, okay, so I ordered new 100 nanofarad or, wait, 105, 0603, 104, and 105. So one's 0.1, one's 1. Which would 104 or 105? Hold on, wait. 105 is what we want. No, 105 is 1 off. So that's, these are 1 UF. I'm gonna write that down on the thing. On the enclosure before I transfer it over to my parts bins. Oh, it's really good that I got all these parts in. The only thing that I didn't get in is parts from Mauser. And the Mauser parts are actually knobs. So that's for the other eurorack modules. That's all mess over there. We're not going to worry about that. We don't need a pen. We need tweezers. We need capacitors. And then we also need LEDs. Where are my LEDs? I've got bins full of LEDs, these little surface mount jobbies. And it's just a matter of finding them down here. In the mess. There. Some of the labels have come off. But those are, I believe reds are here, blues are here, and green is this one. So we'll use these. I'm trying to use these up because these are kind of a little bit older and they've got lenses on them. Hey Bother, hi Al. Hey, what's going on? Goes Lab and Haystack. Oh yeah, and we've got a YouTube chat in here too. Have there been any YouTube chatters? No. No, but it did open up. Just got new 3DS mode working on Android 3DS. Oh, sweet. All right, this circuit board is so small, I'm going to have trouble holding on to it. And I think I'm going to hold on to it where the chip goes on. These loosen up, and you can tighten them again. I need to find bolts that actually work in here so that it's not a smooth screw cap. I actually want to have something I can grip like this, because then you can just screw in the base a little bit more. And I should probably just put thread lock on that. I've been using these a lot. These like duckbill holders that I put silicone rubber hose over the tips of so that they're now temperature resistant. They're mostly metal construction, so I can use hot air around them without melting them. The only drawback is that they loosen themselves up like this every now and then, and so if I actually get just a little bit of thread locker on there, I think that'll be the end of it. I don't have to complain anymore. I'll have nothing to talk about. Yeah, the thermal camera is a Lepton 3.1, which the price of that thing's gone down so much lately. It's really cool to just see the heat propagate through the circuit as you're soldering. But here, I'm going to clamp it down at the location of the two chips, and then that should hopefully, because this thing is so small, I might as well put like 2 pieces of maker beam on here and hold that down, and then, well, no, I don't have screw terminals. Yeah, so this is just going to be kind of annoying. We're going to use the smallest tip. I really don't typically advocate using the smallest tip of the iron because you need to get heat into some of this stuff in order to make it, you know, flow. And of course, this is my 33, what is the mixture again? 3PB37. Sorry, 6337. So silver 63, lead 37 from Kester. And I'm using 0.4 millimeter solder. This works real great. This setup works real great for 0603 components. And so 2 HP is sort of like the limit of the Donkey Kong connector width. And so that's what we've been designing for. It's sort of like the fashionably sized width to do modules in now, because you can fit a very dense amount of stuff in a very narrow board, and it's enough so that your blah blah blah, so that your Donkey Kongs fit Donkey Connectors. So up at the top of the board, I put it in upside down. Hold on, This is Seed Studio, so I really trust their work. They do a very good job. These traces are nicely defined, and I believe they are probably all decently laid out. A lot of our layout was aesthetic. It's interesting when you get the boards to actually see what they look like, because the patterns on them are different from what you were seeing in CAD. It's mirror imaged. And then also you're not looking through the board with the other layer present, so it's a little jarring, like, oh, there was this much room there? I didn't notice. We got a half hour until another ad, so let's get some components down. So on the right and left, we have our red and our blue LEDs, or red and our, green. I'm just gonna do simple red and green for this board build. So what we can do in the CAD software, and this is a selling point for AutoCAD that I don't know, I should maybe less explicitly do it, because I'm not getting paid for this. I do get this copy for free when I do a hashtag AutoCAD ad. So if I look at the properties of D4, it says red LED, LED underscore red in this little pop-up window in the lower right that you see now. Now, okay. There it is. LED underscore green and LED underscore red. When did Twitch people get our ad break? It's in 29 minutes. So I want to install the red LED. So the red LED is the one that works in reverse. So when this goes negative, positive current flow goes through D4 from ground. So from ground, this D3 is blocking, D4 is letting its voltage through to. It's letting as much current as R10 will allow through, and dropping the voltage by what, like 1.4 volts. So the red LED is which LED? So I click on it, highlight it, and then I go to the two-dimensional drawing. And actually, I don't know which end is right and left on this one, but it's telling me that the left-hand side LED is the one that needs to be the red LED, assuming that I haven't mirrored this whole thing. It looks like the component is on the top of the board because the text is straight. It's not backwards. R2 is on the underside of the board. So D4 right there is what we're installing now. And so that's going to be the red LED on the left. And there's a marking on it. What direction does it need to be in? Which one's the anode and which one's the cathode, huh? Doesn't look clearly labeled on this one. Oh, because we're not even looking at the red. So let's pull in the top layer. So top, I just clicked the little eyeball next to it. There we go. So, oh, A and C, there we go. So anode and cathode. So A plus, C minus. Everybody has their own mnemonic for that, but our anode is going to be on the right. And so the anode is the one with the line on it. We can use the multimeter to test that, or I can look at the symbol that's underneath the capacitor, and I've made a note about that on the labeling. The minus is on this little like bar underneath it. So hopefully this is the red bin. I think it's the red bin. We can test with the multimeter, but I'm just going to put it in. These have little lenses on it. I mean, I think a chip LED would be just fine in this application. So the little butt is minus. So this goes this way. Oh, these are much smaller than I thought they were. Wait, these are 0805 LED. We're gonna have to use different LEDs. I have that size. These are too big. Get out of here, you're too big. Can't use up the weird ones. So These are, oh yeah, these are definitely 0603s. I have pink, I have white, I have ultraviolet, I got blue, but we do have green and red. So here's a red LED. I believe the same marking applies. I used AutoCAD when I was in school, but I've been using KiCad. I would have been using KiCad, but AutoCAD came in at the last second and said, hey, buddy. And they said, hey, if you use our software, we'll kind of let you use it for free. And we'll give you some features and not harass you about the cloud stuff. The bins are neat. When tie, but if you just look up surface mount component bin, for stuff like LEDs, it's probably better to have one of those binders. And I should think about, I mean, I can't undo this, but it would have been nice for things like LEDs to have a binder of the sample binders, this kind of thing, where you've got cut tape sitting in a binder. That's what I use for everything else. And I got to decommission a bunch of these. But the when tie, they're really good for like ICs and stuff. And if you are building something, you can take them out of the tape, the components out of the tape, and put it down on this. So A plus C minus, so that end, no, where are you going? It needs to go in like this. See, if I tap it, then I don't know if it flips when it comes off of the thing. Get off. Jesus, stupid. All right, flipping surface mount components is very annoying. Oh my God. It's like static electricity. And now I don't know if it flipped. I don't know if it flipped. There's a little mark right there. It's hard for me to see. I usually don't notice it, but there's a little mark on the one thing. I got to see where the... Son of a... Ooh, that could rip off the lens. I got to be careful. Okay, my tweezers are really frustrating me for some reason. I don't think they're magnetic, might be, but it might also just be flux on the end. I could use a multimeter and probe this, and then it would light up. Peek at it. It's inverted. So the dot is on the anode. That little darkened spot on the top of the LED is the anode. So get this over here and turn on the iron and wait for it to heat up. Ready? 300 watt soldering iron, heating up, 3, 2, 1. It's ready to solder. So the ever tiniest little bit of solder, oops, I put it on the iron, not on the iron, on the pad. Let's focus the camera a little bit. We could move in. Oh no, I'd have to physically move the camera in order to move it in. Which, you know what, for the sake of the visuals, I'm going to do it. Hopefully it doesn't unplug anything. Freeze my camera, and then I got to restart my whole setup. The thing about zooming in with 0603 size is that you'll think that you're simply operating in your normal 0805, which is much, much larger. But the reality of it is that this, shaky, shaky, shaky. This is why I need the 1 to 100 stepper motor for focusing this camera, or to, figure out what the Nikon digital signal is to focus this camera so that we can really get in here. All right, this post is getting in the way, but I'm going to work around it. And then finding, I just snipped off the end of the solder. Finding where my iron is the other challenge. Okay, here we go. That's not how you do it. It's not how you do it. I'm a professional. What you do is you put the iron down on the pad, flat as you can. You let it heat up. You apply your solder to the pad. Then you come in with your left hand, which is being blocked by the post here. Let's see if I can scooch the post without this thing moving too much. There we go. Okay, come in with the left hand, grab your component. Why is there like, oh, it's just sitting on stuff. And flatly slide it in. The post is in the way, but we'll see if I can still pull this off. Nope, I'm gonna have to correct it. Hold on, let me just staple it there. Okay, I'm just stapling it down so it doesn't fly away, because this needs to move way up so that the duckbill is out of my way and I can grab this orthogonally to the board. So these LEDs fight. They don't like to flow over on their leads. I'm not really sure what that's all about, but what I can do is solder the other lead and then go back, hopefully without adding a ton of solder. And you got to be careful too, because if you add too much heat to these LEDs, the lenses will come off. No, 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 we're not soldering that. Stupid. Ay, ay, ay. With my luck, I'd always sneeze at the worst moment. This is how I'm soldering right now. What I'm soldering is way down over here. So my sneeze would mostly just mess up the camera. I am bolt upright because I've got this on OBS on a monitor sitting in front of me. This is how you avoid back problems as an electronics technician in the year 2026. It's good to have a webcam microscope. It's good to own land. Okay, just like that. And then I'm going to come in here from the side, try to make this nice and neat. It's actually kind of hard to come in here from the side. What the fuck is going on with that? Coming in from the side. See, we did all that circuit stuff at the beginning to assert the fact that we're smart. Will this actually heat up the... No, 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 no. Why did it do that? It's like the opposite side of the iron that I would like to be clean and functional is the non-functional side that's oxidized. So, you bastard. It's going to put a giant blob. Yeah, that's what it did. You little bastard. Probably could have hit that maybe with flux, maybe clean the iron tip. That's probably what I'll have to do in the future. Let's just see if we can get this, because we just got to get it in there. So heat it up and then use the iron to pull away the excess. And then if I'm feeling self-conscious about my solder job, I can come in here and remove a little bit of solder from that via that sort of soaked it up for no reason. But again, everything you do at this scale is much clumsier than what you typically think you're capable of. That's all. I'm not... Oh, I removed it all from the LED itself. That was bad. Probably should have done left to right. That might have been a better direction. This keeps bending. Hold on. Need more solder on the end. More control. There we go. You got to do this for every single one. Gonna get good at it. Yeah, these aren't the friendliest soldering pads, but I'm coming back to this one because I want to get a little bit of that flux over to the chip itself, because it looks like it's cold soldered, which can cause all kinds of issues. So that's okay. I guess that's okay. Just because I can, I'm going to test this real quick. So I'm going to get the multimeter and I put it over to diode mode. All this stuff is within reach. I keep it within hand reach. You don't lie. The TC moculars, I like them as they have. I don't know what you guys are talking about. So having side conversations. So positive to cathode, or positive to anode, negative to cathode. That lights up red. Cool. Okay, so that one works. Let's move on. We don't have to test all of them. I just wanted to make sure. We get there's a couple more clamps on this just to make sure it doesn't move. There we go. Okay, so now let's do this one, but let's do it from the opposite direction because I think that's a much better idea. And we're going to make it green. I could do blue and red. I could do blue and red and it would look fancy and technological, but I think I like the basic green and red. You get the cat eating chips. It's going to moat. Like that one. Yeah, during the commercial break, I was mentioning to chat about approximately up, the game that some streamers have been really enjoying lately, and it looks like you can do like full-blown control systems, like PID controllers and stuff. I tried to say trinocular microscope with a camera, but my brain was like, screw it, and just look, guys. As much as I have a responsibility to you to not confuse you guys, I believe that Twitch chat has a responsibility to keep me from confusion as well. I am tempted to do the right side again because I'm right-handed. I guess that's just how it goes. Whatever, I've only got so many of these to do, I might as well be comfortable while I'm doing them, so let's do the right-handed one again. The other 0603s usually aren't this annoying, but having to get something in here and have it go in polarly, have it have the right poles, is kind of annoying. But the more you do it, the better you get. So my pads leave a little bit to be desired. I think I need to redesign my resistor and capacitor pads to be a little bit larger. Yeah, it's good to see new viewers. Oh, viewers being confused, yeah. So Monkey Wrench got picked up by Netflix, which is pretty cool. I wonder if that means Joel is going to become a Netflix actor. Voice actor. They'll just do Skeletor the whole time. But that's cool, though, for Monkey Wrench, though, because they were, it's a indie cartoon, and they were in kind of a limbo there for a while, not knowing if the not quite enough Patreon money, why did it do that? The not quite good enough Patreon money was going to sustain their efforts to get the whole series out, but it seems like with a boost from Netflix, they might actually get beyond, you know, across the finish line, assuming it's not a typical Netflix, like, hey, cancel that. I don't think it will be, though. And they've retained most of their creative control and control over some of the stuff, because Netflix didn't do like a full rights. They're just picking up the series. But hey, that's really cool. Good to see some success out there. Have you seen the cartoon Dig Man? No, I haven't. Parody of Nick Cage and National Treasure. Oh boy, Nick Cage. I got a love-hate relationship with Nick Cage movies. I mean, when he's good, but when he's bad, he's trying to be bad, and that shows. Twitch needs an edit button like the old chats in the 90s. Yeah, well, it's based on IRC, and I guess they want that finality of content, of comment. It would really be, like, the gaslighting would really be serious if, and once again, it does the thing where it doesn't go to the pad, it goes directly to the iron or stuff near it, or it just backs up. I do not understand why this is happening. I mean, I am also coming at it from a funny angle, but why? Time and time and time and time and time again. What was that? Oh, I just had multimeter probes on my foot. Twitch has been unusually stable the past couple months. I've had some weird stuff. Like, I've been watching Sput stream, and for some reason on Sput's stream, the ad blocker causes weird audio glitches. I don't know if that's because Sput went 2K. I didn't see 2K options in there, but it was very weird, very strange behavior. I want to see that solder up on the top of the chip, because these LEDs have a big solder pad, and it doesn't often solder all the way around. Look at that. That's not going in cleanly either. I wonder if this tip is just cursed. All right, that's one set of LEDs. Next set of LEDs would be 1, 2, 3, 4. These two. Wait. No, it'd be yeah. So input, out, 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 input. So it is these. I think got the line on it too. Don't have ad blocker? Yeah. No, that's not a new tip. I haven't used any of the new tips yet. I probably could be using a new tip. Well, actually, no, this stuff is smaller than that. So on the right side is the green, on the left side is the red. Green and red LEDs to indicate what your input is, if it is positive or negative. If it is both, then both. Whoa there, twitchy hands. Call me Twitch Hands Luke. I really suck at gunplay. Can't hit a damn thing. What? Look at that. It's like static electricity is attracting this thing to my damn soldering iron. It's annoying. I hate Twitch's AI overviews. I joined a chat the other day, and it was like, Streamer X is killing morphed animals to make clay. What the fuck? There's an AI. Well, there's AI everything. It's... I hate it. Where's soldering iron? There it is. See, that was textbook right there. Let's see if we can get this to slide in and actually like solder in a little bit. The important thing, and I'm showing you the other views so that you guys can see where my hands are. Look where my hands are. Vsauce, Michael here. So that you know that I do not have steady hands, I simply have braced grip. Now that's not melting it again. I can't move it around. There we go. I could always hit this with hot air afterwards and try to clean it up a little bit, but what the okay, all right. I'm calm, I'm collected. I'm in my element. I'm thriving. There we go. Let's get the red LED in. And then I'll spin this and solder the other side and see if that feels a lot nicer. If it probably is worth my time considering how much I reworked that other pad. Try to only pick up one of them. What the? I did not, in fact, pick up only one. And then I lost them. They're over here. All right, well, there's one. There's just a red LED sitting around the table somewhere. Ugh, now I don't know which one it is. Where'd you get those horizontal clamps? Yeah, Amazon, and I just looked up circuit board clamp and found these magnetic ones. And then I happen to have a giant piece of steel to put under them that's painted blue. I do kind of wish it was gray. Maybe I'll get spray paint out at some point. These I can't push down on the top in order to flatten them because they've got plastic lenses on top. Might be able to take it, but I don't want to push my luck. When you see me roll the soldering iron like that, it's to move stuff to the side because sometimes things get like caught and I need a tiny amount of distance with a lot of torque on it. Because like sometimes I can't move laterally or whatever, so I try doing a little twist. Oh boy, I can't keep up with chat, guys, because I've got to work. I gotta work. I'll read chat in just a sec. Where'd those LEDs go? There they are. All right, so keeping with my right-handedness, see if we can't get solder in there properly. And I got to be careful about the iron tip too, because I'll poke these lenses and it'll melt them. So I'm going to apply heat and hold it there. Come on, bud. That was pretty good. So if I can actually get that to wrap to the top. Luckily, we only have to do 4 of these mofos. Only got to get 4 of these. I don't know if I'll hit them with flux. I don't know if I want to do that. Why is it so blown out color-wise? And then look at that. It caused the rollback on the... Hate it. You found them. Nice. Okay. They're pretty good. I mean, I had to replace the tips with silicone rubber hose so that it wouldn't melt. Like, I just cannot win with these LEDs. These LED chips just don't want to solder for me. And they don't want to solder to the top layer either. Seems like they just want to be soldered in with hot air. What if I added a little bit of tacky flux to these? The lenses are so bright, they're completely blown out. It's crazy. It's crazy. Crazy town. It's crazy. This means I really got to clean them off when I'm done. Ugh, it's too much tacky. Everything is so much smaller, it really does make you feel like you're Batman. Now, it really does make you feel like you're incompetent, but it really, everything is tiny. What the? Green LED? What was that? Was that for bits? Green for bits. Hey, thank you for the 200 bits, Veet. I hope they're useful for you. Again, like you saw me doing earlier, grabbing them with the wire stripper and tightening them at the beginning of using them, and then of course the silicone rubber stuff really helps out. So like that one crept over to the top of the lens, or top of the chip rather. There's a chip and a lens. And the pads are the clamps, the C-shaped clamps on the sides. All right, so now if I take the multimeter on diode mode, I want to check this over now because once I put those sockets in there, I'm not getting to these again. Maybe for cleaning, but not really for much else. I have only one. Okay, so if I go one direction on one, green, and then flip, trade places. That one should be lighting up over there. Hello? You. No light? Flip. Uh-oh. Uh-oh. Green. Flip the leads. Red. Okay, phew. I was going to say dead. No, okay. Green and red, those are installed. They're probably not pointed right, but whatever. We're just building the test one anyway, and this one's going to be the most tortured version of our circuit. The next thing we need to install are some decoupling capacitors. I didn't have space for them anywhere else on the board, so we're going to take 0.1 UFs. Now, excuse me, as I burp, I've had meatloaf for the past 2 meals, which is, you know, basically just a bunch of, it's just a giant meatball that you put ketchup on. That's meatloaf. It's very good. I wish I had collard greens with it though. That's anyway. Point is, my stomach is an acidic nightmare. The 0.1 microfarad capacitor in digital stuff is. We got 2 minutes until an ad starts. We got time for this explanation. The 0.1 microfarad decoupling capacitor exists in order to decouple your chip from the power supply. What that means, decoupling means, is that when you have a current surge from your device, or in the millisecond that your power supply turns on, the T is equal to 0, means that there is basically a short circuit right next to your chip. And as that inrush of current comes in, it will charge the capacitor first before it gets to your chip. So actually, physically, the 0.1 microfarad capacitor should be in front of, in terms of in line to your power supply, in front of your power supply, so that in the milliseconds that everything turns on, you know, it can filter out any inrushes and your chip gets power all at once. The thing is, a lot of that, what I just said, does not really stand to reason when you get down to the nitty gritty of what's actually going on in the actual electron flows and the actual milliseconds leading up to time. It doesn't really quite work out that way, and it actually turns out you can have a much larger capacitor in line with your power supply, and because we've been getting better at building electronics, you can find capacitors that are huge that can fill the space of that 0.1 microfarad cap and do a better job in case there's like little surges in current coming from your device. But in the end, I mean, what does it matter? We'll just put 0.1 UFs in anyway, just to be traditional and have that filtration in place. Now we're going to go to an ad, so I'm going to talk about waffle, get a glass of water while we're doing it. These ads, they pack them close together until you run 2 or 3. I'm thinking about maybe during the intro, I might want to manually run like a bunch of ads, and then that way we get like a full hour between our ads plus. I think that's the strategy going forward, is during the time when I'm just talking to you guys at the beginning of stream, I'm going to run a couple ads and see what that does. How's buddy? We're doing some very, very small soldering, so you guys have about 20 seconds and then you're going into an ad, and when we get back, yeah. Well, V Nukem, thank you for the bits, and Lionel Shadowcat, thank you for the streak. I don't really need to say anything to those, but whatever. Juicebox Hero subbed 6 days ago. Jesus Christ. Oh no, wait, yeah, that was 6 days ago, so I don't need to say thank you for that. Things are quiet. We're building a circuit board that we just designed, so the ad is starting soon. That's just like nebulous, like, we'll run an ad when we feel like it. There it is. All right, so I'm gonna get water here. Yeah, I was thinking of getting approximately up the game just to teach myself PID and have it be a little bit more intuitive, because I think that game could really teach you PID quite nicely, experimentally instead of mathematically, which is the way I learned all of my control system stuff. And I saw there's on the what is it, the workshop, there are a couple like PID controller kind of things, but you don't need to go into the workshop to do that. The game gives you all of the math functions that you would ever need. It's even got like arctan and stuff, so if you really wanted to get into like hardcore matrix algebra control systems, you can, which I find fascinating. I think a game with little spacemen that have giant heads putting together boxes that have jet engines and distance sensors on them, and having that implement fully blown, like full force control system moonlander shit, like that's awesome. I think that's a really good game. Unfortunately, my LAN friends have fucked off and gotten lives and spouses and responsibilities and stuff. So we haven't been able to do a LAN party in quite a while. The whole purpose of the LAN party was to take us out of our lives so that we could have a day where we could play video games. We haven't done that in a little while. And so I would be pushing this game on them, and while they would be building the actual ship itself, I would be frolicking about and like building just like a framework that I could do control systems weirdness with, to be like, ooh, look at that. It's usually a pretty good dynamic. I can just kind of, you know, tra-la-la, skip around and do random stuff. Like in Factorio, they were building the factory. I put a solar panel on night vision goggles, and I was running around in the dusk and dawn, like I can see everything, and then everything would go dark when the sun would fully be down. That's the kind of stuff I get up to. So we still have to pick values for components here, and I have to figure out what this circuit is going to be. It turns out I did not build this for Unity Gain quite. I built it for whatever the hell I got in my brain, and it wasn't quite the right thing. So a lot of the values of this, I think, like R8 is infinity, R7 is probably going to be 0, although I'd like it to be something like 100K, and R9 is 1K in order to decouple the power supply, or decouple the amplifier. If I make R7 100 and I make R8 infinite, that pushes the transfer function to infinity, doesn't it? And so it'd be 1 plus infinity, so it'd be full gain. That doesn't make any sense. So 10, 9, 8, 7, 6. Green light. Sweet. Okay, that works. That works now. Good. my Node-RED flow functions. Hey, welcome back. We didn't talk about anything of consequence. We got to install some 0.1 UF decoupling capacitors, which, as I explained before the break, aren't really necessary. I mean, if you don't have 0.1 UF, if you've got 1 microfarad, these will do the same job. It's really the same thing. In the analog audio world, I'm not sure what the 0.1s are doing. I think they're there for surge current, but when you turn the thing on, 0.1 UFs aren't going to prevent you from hearing a thud in your speakers. So I need 4 of these, right? It's only on... Oh, and then 2 for the power supply, so 6. So I'm gonna dump 6 of these into a bin. Do we have like a bin kicking around? Usually I have a spare bin just kicking a boot. Yeah, here it is. Just a spare bin where I can dump stuff off of tape and reels. And these will eventually get their own bin in my setup. They won't be a cut tape kind of thing in one of the binders. I got to get back to the arcade setup. I have to get back to the burn the subs. I'm trying to clear out the synthesizer stuff so that I have a synthesizer that I can play. Okay, that's 4, 5, 6. Okay, there we go. Of our 0.1 UFs in 0603. I want to have the synthesizer to play while we're doing the other stuff, like the CAN bus stuff and the, you know, burn the subs. A lot of programming that we have to do for that. So I'd like to, you know, work on this stuff, get one of my designs out there. I would love to be able to produce an actual synthesizer module. That looks crooked, doesn't it? Looks like it didn't settle down properly. I may have to take hot air to those. Let's get these down first, though. These are just decouplers. Yeah, those the LED, you know what it was? I got a bunch of footprints for LEDs from something. And the something might have been Thingiverse. Actually, it might have been something attached to Fusion part models. Or I just found it randomly on the internet. It wasn't very generous with the pads on the ends, which might be good for a design like this where I'm kind of really space constricted, but that means that soldering them in with my normal soldering iron was very difficult. Very hard to get purchase on the pad. So, ground pad with plenty of heat strain. Go there, go here. Looks like too much solder, and it might be. And now we grab a 0.1 UF from the bin that I can barely see. Where are we? Where am I? There we go. And see if we can't. Could you please? I'm so sick of components sticking to these tweezers. I don't think there are tweezers that I will be comfortable using. That's the important part. Like these dull head spoon handle, I call them. That's not the right term, probably. Spoon tip. But anyway, the type of tweezers that these are really comfortable for me to move stuff. My iron turned off. Move stuff around on the board and, you know, orient things properly and get stuff soldered. But for some reason, the material that these are made out of, maybe their age, they get stuff on them or they get static electricity or something, and components will just stick to them. Which is more than a little frustrating. I'm being kind of stupid about orienting this thing. The real way to do 0603 is with solder paste and a skillet, but this is a two-sided design, so please. Yeah. All right, that one's in. Let's get another one. God, this really makes me, you feel inept because all of your movements are huge. Because all this stuff looks like normal size, but it's all very, very small indeed. I would not consider that fully soldered in yet. Damn it. With the giant soldering iron tip doing stuff this small, I can actually come down on the pad and hit it and it'll heat both pads. Oh, it looks like we totally lost our ability to get heat into here. There we go. And then I lift the chip. Oh, cool, cool. Very cool. I lost all my solder on this? What's going on? I think, so the way that I'm perched for the tweezers, I think is the problem here. Yeah, I'm moving my hand because it's totally stupid. Plus my chip is at a weird angle, so let's get just like a little bit of extra solder in here. If I add solder to this pin, what's going to happen is this is going to lift up. So what the that is so frustrating. Yeah, I think we need to move off of this tip. I think my tip's fighting me more than anything else. This is nice to get precise heat in there, but I'm going to flip over to a big one. Yup, if only I finished the manual pick and place, which is sitting in multiple different places in the shop and outside of the shop. And it's a little bit of work to get to the end of that. I mean, man, you guys, if I had a real budget, first of all, I'd have paid off my credit card. Second, I might just buy the manual pick and place. Yeah, see how much easier that is to just get all that heat in there immediately? And it just capitulates. That's it. So now I'm going to go to the other side, but I'm going to flip this so that I'm still working with my right hand on the iron. And so we've got both our caps sitting right there. This is just, I mean, it's clumsy, but it's also, it'll hit that pad immediately. So I need to make this sit down, and I don't want to put torque on either of these end caps. So what I'll do is I'm just going to add solder to this side and hold on the chip for a minute or two, or a couple seconds really. And then I got to nudge it just a little bit. All that heat is bleeding out into the ground plane, and I do wish I could have a microscope thermal imager. I think it's possible. Okay, these aren't going to let heat go through, are they? So we'll come back to that. Let's get this one. This one's being a good boy. That was not good. Give me that. Clean, clean, clean. Back over to here. Yeah, see with the bigger pads, I can do that. And here, I can try this. Hopefully it doesn't lift the whole part. I don't think that's working. Trying to hit both of them at once. So this sits down again. No, it's not going to listen to me. Okay. You teach a class on soldering, you can always do it much cleaner than I can. Anything on YouTube is going to be cleaner than what I can do. Watching how much solder you're adding to the pads is also kind of really helps make it look cleaner. But I appreciate the compliment, because coming from somebody else who's actually tried this size, you know, it's easy to just say, it bothers no Louis Rossman, but it's like, I do pretty good. All right, so the other set of decouplers is here, and then the last set is on the other side of the board. I like watching the people on YouTube. I try to be entertaining above all else. I could do with a little bit more like wackiness in the projects. Sorry, I'm spitting at this because I can't use curse words. I'm not allowed to use curse words because my theory, and it's just a theory, is that YouTube probably still censors you if you curse a lot. That's my theory. It is literally a conspiracy theory because YouTube has said they don't do that. But I don't believe YouTube because they never, ever depreciate a project. They just throw it at AI more. So somewhere baked into their algorithm is going to be something that says, you said a naughty word according to the Puritans, you're not allowed in the new America, and it censors you from all further algorithmic suggestions. Ooh, I was about to hold my breath there. I'll read chat in just a second. What? Didn't turn off, but it also just stopped allowing me to get heat into this. What are you doing? Oh, geez, what is going on? I think the actual chip capacitor itself started sucking up all my heat. So hold that until it gets molten. Bring it in. Let it touch off for a minute. That's actually what it should look like a little bit. Okay, what's going on? Playing in the RF bands myself today, got an emitter and receiver, and I'm plugging in a prototype. I was hoping that I could really kind of flex my scope today. I don't know if we'll get around to it because this building is taking a lot more time as I tutorialize it, as I tell you guys what I'm doing while I'm doing it. It takes me a lot longer to build stuff, but the powered MULT is going to have certain frequencies that it'll like and dislike. And the way that the MS-22, the 3 toms module, is tested is by using Ableton. And I was like, man, I don't have Ableton anymore. I don't even have the pirated version. I don't want to install the pirated Ableton because it kind of infects your whole computer. And I was thinking about it and I was like, well, you know, I've got the DSO 940. This is a pretty nice Rigol scope. It has a lot of features, and I'm thinking maybe an audio frequency analysis might be totally possible with my scope. If I kind of knew what I was doing a little better, I wonder if we could have done more sort of RF and audio frequency stuff with it. So the troubles that I'm having are old soldering iron troubles. And the old soldering iron troubles being that it's not transferring heat properly. And I think one of the solutions is to come at these from a lower angle because there's not a lot around them right now. The lower the angle, the more pad I can get onto, well, more pad to iron contact I can get. And then just wait for the heat to propagate. Yeah, see, that was textbook. Why'd you emphasize it like that? Ah! Slipped. That's the only problem with the duckbills. I call them duckbill holders. They sit very high up from the table. And so I'm having to come up with new ways to kind of get at them. Get at the circuit board when it's being held by these things. Let me move a little closer. I mean, I've been like putting my hands on the tops of them and moving like that. And that's been the best way to kind of maneuver around stuff when these are in use. So we're flipping the board over. I'll just quickly inspect these. Those are going to be in weird directions. This is just the prototype though. I mean, the real thing, I don't know if, well, the real thing's always just going to be a hand-built kind of crazy town circuit. That one looks like it could probably sit down a little better. But it's still connected and it's still a 0.1 microfarad capacitor, so I'm not really going to push it on that. I'm just going to leave it the way it is. So we go to the other side now. I'm going to put the 0.1s in just because we got them out, because that's the total number of 0.1 microfarad circuit, 0.1 microfarad capacitors that are in this entire setup. But once I do that, we need to get back to installing these things in order, because they're going to start blocking each other because I didn't have any room to design this thing. My cheap way of avoiding buying a flight controller chip, to a $200 chip, I got 4 remote control helicopters and I'm going to use the rotors for a makeshift drone. What? Wait, so instead of doing like a cheap Ardu pilot with some kind of PID circuit in it, you're just brute forcing it with the cheapest of the cheap. You should watch that DARPA lift challenge that's going on. DARPA's having a helicopter drone lift challenge, and there've been all kinds of designs. I have seen somebody with an old school RC helicopter, the ones where you had to get insurance on them because they kill people. Nyano, speaking of, Nyano Cat, thank you for subscribing for 29 months. When did that happen? Holy. Nyano Cat, thank you so much. Speaking of killing someone, we also need some Schottky diodes. Schottky diodes have a very small voltage drop, and so they allow you to have basically flow control barrier diodes in your supply lines. As long as this hovers, I'm happy. Tried it once and rebuilding now. I kept getting a voltage drop across 2 rotors. Huh. Knock down Linux on a Raspberry Pi. What are you up to, Jay Nico? It sounds like you're doing some real mad scientist kind of shit. It's cool. See how shaky my hand is? See how shaky that is? You can also see the effect of the solder finally flowing over. I see there's my markings. Powered MULT. And then I put this thing up here, and oh boy, you can barely read that at this font size, huh? Probably need to have slightly larger font. It's a confifi hat. It's a chef's hat right there, guys. Why are you guys like this? This is a chef's hat. You don't have to worry about it. All right, let's get back over to here. So these are just extra 0.1-UFs that I took out just because I was getting them off of the reel. We actually can go component like value by value because we've got the CAD program's ability to highlight multiple things at once. And it'll really help us just kind of get all our ducks in a row. Nope. Tombstone. Man, you guys remember Chuck Testa? With those sort of like meme ads where they try to go viral? I try to get in on that trend. I was late enough in my post that it got completely fucking hounded. Reddit was not having it. That meme had a shelf life of about 20 minutes before the internet started to get mad at it. And it was back before we had all of these covert AI campaigns pumping up engagement. I wonder what the people who did those ads are doing nowadays. Probably something a little shady. This is off by a little bit, and I'm not going to let it bother me. I'm not going to let it control me anymore. You have no power over me. You can't scare me. That one's nice and clean. This one needs just a little flux from the rosin core. There we go. That one looks professional. Although the chip itself, the component itself, is probably all cockeyed because of the just it moving around while I'm trying to get solder into it. So let's get the last one of these in the bin. The last one of these in the bin. There we go. Hard to see, hard to grab. One thing that I've been doing with these is grabbing them and then pushing down on them with the iron just to flatten them out. And this is connected to ground, so I need to get good contact. Slide it in. There we go. Smooth as butter. And just make sure we stay away from the uncovered via. I probably could have put covered vias on these. I use the uncovered just because they create a nice test point. My AI wants to fly. Oh boy. Well, AI is in the algorithm, or AI is in like you put a learning language model in control of a rotor. Oh, gee, that wasn't even soldered. Wait, that wasn't soldered. Do you see how that moved immediately when I bumped it? So that looked like it was soldered, but it wasn't. This is why we inspect from an angle. Guardian angle. These can tend to lift up a little bit, and when they do that, they don't solder down. My hands are cramping. I forgot to get a glass of water during the ad break. I've had a lot of trouble with the iron tips lately. I don't know what's going on. Maybe my tinning process isn't so good. See, that didn't even solder down. Now it's soldered. It may also be crooked. We can come back in with hot air if we really feel like correcting it. I keep saying that. We'll clean that up later. We'll clean that up later. Schottky barrier diodes. We can do those now. I know where those are. Those are right here. No, they're not. Wait a minute. Where are they? Shit. Used optos. Here they are. I was considering whether or not I wanted to use F beads, but I just don't think I'm into it. Ferrite beads, F beads, or an ESD capacitor. I could have put on this thing too, but I think that may be too fancy. The ESD capacitor is better if you don't have a TL074. TL074 is kind of a workhorse operational amplifier. But I've got these guys, these 1N5819 Schottky diodes. I have a couple of them, so I'm trying to use them in every design. For the eurorack stuff, they're a little bit out of spec. They get kind of warm with the 12 volts, but they are within their capabilities, so they should be okay. So let me just grab two of these and put them moderately close to where I'm going to be soldering them in. I have a couple of them to use, so I kind of want to use them in this design. And back over here, yoink, and then here they are. And so the little dash is the flat part of the diode, which indicates the direction of current, according to Ben Franklin, I guess, which is the opposite way that it should go, but it's what we get. And it's what all our equations in math are based on, so whatever. Try to flip that over, there you go. That one needs to go in this way. God, is it already current time? Jeez. I'm supposed to do shrimp scampi tonight, which doesn't really put me on a hard deadline, but it does mean that I've got to be a little careful about how long we go for. I don't know if we're going to be able to finish tonight, but I will certainly be able to show all this stuff and, you know, go on tomorrow, and we'll keep plugging away at it until we're done. So there's my anchor. It's facing the right direction. Hand is, of course, shaking all over the place. These I can at least push down on the leg a little bit to get them to be flat against the board. And that's like off by a bunch. Yeah, the manual pick and place solves a lot of these issues that I'm having with like my hands shaking and stuff because I've perched it weird. If I do this grip, maybe I'll get a little bit more stability here. Let's try that. Where I'm actually, my hand is around one of the pillars and the pillar's in my palm. Not as easy as I would like it to be, because yeah, that's still weird. I just like scooch it on the board. Problem is the surface tension of the solder itself is gonna mess with me. And if I could heat both pads, and that's what hot air does for you, then it would move a little better. But right now it's in there kind of crooked and I can't do much about it. So I'm just gonna leave it and we'll come back with hot air and rework it. And it'll settle in once we get hot air on it. Hot air is like a necessity these days. You can't work without it really. You can do decent enough work. It's just, oh, that was abysmal. That was real bad. I just put a little more solder on there just so I feel good. No, it didn't go. It went on the iron. It didn't go on the pad, of course. I'm calm. I'm happy. Everything is fine. We'll fix that later. I just got a soldering iron. I'm a bit afraid. You should know how small this stuff is. We are working in an advanced size. If we were working with, for instance, 0805 surface mount, 1202 surface mount, then we would be in a much better place. I would be a happier person. women would love me, and men would want to be me. But we are working in 0603, which is much, much, much smaller, but they're all square components and stuff. They look the same. So you don't know that you're actually working in a completely non-human size of surface mount. I've been getting better at working in this size, but I am a professional and I've been doing this for tens of years, and I've got surgeon steady hands, ladies. But that just means it may look a little easier than it is. This stuff is not that hard. If you got a good microscope, you can do this stuff pretty well. If you have needle point headlamp / magnifying goggles, you can also work with this stuff. It's a little bit difficult, but it's just like for big surface mount sizes, it's actually quite easy. I prefer it over through hole. Through hole, nice and easy. Everybody's happy, except for me, because I hate having to flip the board and having all my components drop out. Where is my heat? So don't be intimidated by all this. This is, oh bother, has created a lot of his own demons here that we are then trying to slay. Why did that take so long to heat up and then it didn't heat the pad at all? Probably because Flux didn't properly couple the iron tip to the pad. If we come back, again, if we come back with hot air, everything will rearrange itself. Good thing I don't like needlepoint. I have a set of those needlepoint magnifiers. That's what I'd be using right now instead of this webcam microscope that I built, because it is so much cleaner and easier. Now, the order of operations is important here. I actually probably shouldn't have installed those things, but I need to put in a part that's not going to allow me to use hot air near it. So we might as well pull out the hot air, and I'll heat up this area of the board and get these components to arrange themselves a little bit before I put a big soft plastic thing in that'll melt. Working in circles, circles in circles. Through holes when you put things in height order, nice and snug, and actually pre-tinned. Well, this is pre-tinned and everything is nice and snug, and we are in fact putting things in a particular order, but this is surface mount. Surface mount and through hole just refer to how you're soldering the devices into your board, and in this case, the pin header there that brings power into the circuit is going to be through hole, while these components are surface mount. Now, when you put a big header in like that, these headers are built out of the cheapest of the cheap plastic. And so what'll happen is, if you heat them up like I am with this thing, with this hot air gun, it'll melt. So we got to do this stuff first. I don't know if these are going to rearrange themselves. I don't know if we get that luxury with these. But now that the board is hot, I've preheated the board, I can come in here with the iron and possibly nudge this a little bit. Or if I'm not careful, I'm going to put my finger on the side of the iron, and that stabilizes me a little bit more. I pushed it all the way. Come on. Now I'm screwing it up. Darn. Well, okay, I gotta fix that. These, the board holders are not really helping me out. They don't allow me to put my wrist flat. Let's see if we can move this. Okay, let's, hold on. I'm gonna try to rescue this. So I'm gonna put flux on either side, just so we really get our heat into here. We didn't need to do these yet. I could have waited a little bit more. There we go. Got flux all over it. Let's heat it up. Slowly from afar, and then we'll work our way in. I'll try to get it so the flow of air kind of pushes it back a little bit. There we go. There we go. Yes, back to your home. Yes, all the way in. That's right. Good, good. That's what we were looking for before. I guess copious flux is the way to get around that. Come on. You must capitulate. Yes, rearrange yourself. Move to my liking. Okay, that's good enough. All right, I'm not gonna stress the hot air stuff because this board is going to be janky. That's the point of it. I'm gonna let that cool off, and then I'll flip it over, and we'll do the through-hole power plug, which I then have to trim. Actually, no, we should avoid doing that as long as possible. So first, we have to install. We got all these in-between pieces. Ouch, ouch, board is hot, board hot. Why touch board? We need to get these in because these are gonna block the ICs. Let's get our 7804s out, our operational amplifiers, and just so we can see one against this thing. That's gonna be in the DigiKey order somewhere. I ordered a ton. I ordered like 50 7804s. We need a lot of parts for a lot of these modules and stuff, so what's up, clown? I can just call you clown right off the bat. It's so nice. Comparator, 2-channel. Oh, those are the other ones. LM393. Here's a big reel. That's probably it. JFET, 4-circuit, TLO74, CDT. This is just the cheap one that DigiKey had on the thing. So here's our 7804s. I have a bin where these will go eventually. Yeah, generally with a PCB, you want to work in height order. But in this case, I did a couple little things that are kind of like no-nos for PCB design, which are collisions between through-hole and surface mount devices. So we have to go in a particular order for this. I hope this is way more than what's... My dog has had a very scary day today. It's been a very scary day for Willow because we've had garbage people here who made a lot of noise. I took my recycling up, which made a ton of noise because there's way too many bottles of liquor. And then I've had like a giant package delivered, which was like it's like a end table thing to help Willow get up onto my folks' bed. All kinds of stuff that's just been completely and utterly terrifying for my poor little puppy. She likes a quiet afternoon. For a dog that makes as much noise as she does barking, she really does not. She could dish it, but she can't take it. The DigiKey package, yeah, they're really nice. The dude at the FBI Technical Center's electronics building thing they have like multiple different buildings. Oh, wow. I hate the markings on these. Oh, I hate them. Well, these should be okay. 074C, I think, is fine. But the guy who managed their little like electronics shop in the particular building that we did the IED thing in, what he would do is he would have these giant industrial cabinets with tons and tons and tons of these little bins in them. And in the bin was a cutout of the label for DigiKey. So when something would run out, he would just grab that label, bring it back to his desk, and just look up the number and then be done with it. There's a possibility. I'm going to pause there so that the song can be in everybody's head. There's a possibility. There's a possibility that I could actually install this and then put the plug in. And so we could technically rework this either with an oven or with hot air. I'm going to try it. I'm going to try it with this one. I don't like how primitive that chip printing looks. I really don't. I think it'll be okay. This is the cut rate TL074. I've also got, that's an 1137. What was that doing there? I have TL064s that we were going to use today, but these came in the mail just in time, so. I don't know what it's from. I forget what it's from. So we're going to try to get that in there and then put the socket in. Yeah, school designs, through-hole stuff, I guess that works. And it also means you can troubleshoot it better. But if you use 1206 sized surface mount, and you'll have to, SOIC is a standard, so you'd have to use ICs that are this big. It is not that hard to work with, and I can do field repairs in this size. But this is 0603 for the passives. which is pretty small. And then 2 HP is 2 horizontal rack positions, which is the width of a Donkey Kong, which is the Donkey Con is the connector that's commonly used in eurorack. And it's just super available, and they're good jacks. They work really well. They hold on to your front panel. And so when you build something, when I'm building something in eurorack, I'm using tiny electronics and a 2 HP width. I am just jostling all over the place. I've got to get a better grip on this stuff. What is going on? I'm trying to force myself to immediately work with this, to be very quick, but that only works when the board is down on the table. I don't have a lot of places to put my wrist in order to stabilize my little shakiness that's been a recent thing with me. I'm getting old. I should probably work out a little bit more. Muscle strength in your arms are going to oh, God damn it. Same as it is with shooting guns. The stronger you are, the more stable you're able to hold things as your muscles fight other muscles. Anchoring myself with my hand is, while it works, oh, come on, man. I think it's because this one has a little solder on it. I like lost all control. I'm trying to just grab these pins and pull them. Iron's still on, iron's still on. Let me get a higher angle on this. You know what? I think that song is from Twilight. All right, you unsolder. Yeah, that's the problem right there. Try to sit that pin down without it soldering to anything. At least now I can slide it around. I didn't really have a plan today, so this is a lot of ad-lib. So that one's not going to allow me to solder there unless I can get it. I think it's just because it's to the side a little bit. So I think if I can correct this. What? Oh, it turned off. My iron turned itself off. And now we are under the temperature that would allow me to solder. Okay, thank you, IntelliHeat. Really appreciate what you're doing out here. It's like Intella, but it's also heat. Basically just means I need to keep hitting a button on the soldering iron, or it thinks that I've fallen asleep in bed with a cigarette and it turns everything off. No, I don't want to stick it down with flux. I'm trying to solder the one, and then I want to get the opposite one, and then I'm going to try to install the jack and see if it installs cleanly. Because there's a possibility... There's a possibility that I'll be able to sneak the pin through in spite of this thing being installed. The problem is I'm using techniques that work without these board holders. I could probably just tape this down and work with it like that, like you would typically. Instead of having it so high up on the desk. But I want to give these board holders a try. So this is very close. Now this is also, it could go up a little bit from where it is. I think maybe if I just solder the opposite corner, and then I can nudge it into place. That looks off. See that looks like it's low. Should be up a little bit more, just so we're even on the two pads, so I can get to that one. So yeah, let's try to lift it a little before I do the other side. Yeah, it's garbage day. It's also hovercraft day. It's when the regional champions hovercraft team rolls around on all of our grass. And I immediately screwed myself over. Every movement is wrong. Okay, That's a little better. I would like to sneak up a little bit from there, but I can kind of... No, I can't see it. I think maybe I need to install the jack first. I think the Donkey Kong has to go first. The balance would be if I could just get this thing snuck forward enough that I can get to the side of that pin. Let's just see. It's the lawn care equipment. Sounds like hovercrafts rolling around. It's an in joke. Shit. Fuck. Shit. No, don't curse. Don't curse. Don't curse. Don't curse. You're above that. You're not. I'm not above that. I really need to curse. I'm sorry. Oh, I could spit. I'm so mad. Also, I don't know if I centered this one as good as I could have. I could have probably measured distance in CAD. No, too far. Too far. Too fart. Yeah, I think maybe I'm not centered because like I can get to that pin just fine. This one is a problem, and if I try to install the jack, I'm just going to try to install the jack with only the one anchor pin done. I'll just be careful. My hovercraft is full of eels. Okay, so that one goes like this. The one pin is totally covered. Can I get it to... Yeah, not really. Okay, so we got to install the jack first. It's not gonna let us do that. Let's get this out of here. Just with Mark 1 eyeballs. Doink. And then get the jack in there. Get my jack on. You hear me, chat? Yeah. There you go. I gotta kind of hold it here with my hand through holes like this in order to keep this thing oriented correctly. I could tape it down. I could do all kinds of other stuff. But yeah, you can see here like that. I've pretty much minimized the size of this. There's not really much I can do. I've got to solder these and, well, clip them flat and then solder them and then make sure that they're flat. So I'm going to use the flush cutters here. Pipe wire? What is that? Oh, for like soldering pipes together? So yeah, flush cut, then solder. I'll have to make sure they're properly oriented. I guess they'll be good enough. Here, I'm going to do it like this. And this is where I need 3 hands. These Donkey Kongs do not like getting heat into them. You can kind of break them by just soldering them the first time. So I've got to be careful about this. Actually, you know what? I think I can clamp the whole thing and that'll hold it flush. Oh, happy day. That's actually holding the whole thing. Sweet. Now I don't want to press down too hard or it'll fly away. Can I get the whole thing? No, I can only clamp it from the side, so it might be cockeyed, but this will help me get just a little bit of solder in there so that it'll hold it down, and then I can fix it later. Hello? Why do you betray me so often? Okay, there we go. A lot of this has been me fighting the soldering iron for some reason. Looks pretty good. Only a little crooked. These pads don't really let you go that crooked. I guess I can hold it by the board now. And we'll get the other one soldered, and then I'll check to see how flat they are. I'll probably have to use a file on them a little bit. Also, the chip itself can be a little bit weird. It can stick up a little bit if it needs to. SOIC size is pretty forgivable with that kind of stuff. Oh, we got ads in 2 minutes, folks. I'm going to keep working through this ad. Just know that I don't have anything to talk about. Really don't have anything to talk about. That's bother. He doesn't have anything really interesting to say. All right, how flat is that? It's flat, I will give it that, but it's not completely. The flush cutters got close. So I'm going to have to bring in a file, and for that I just have a little triangle file. That should do. This will do. And just file it to be totally flat. Now I probably should use Captain Tape around the filing area. Yeah, if I slip, I'm gonna mar the board. Also don't want to uncover anything from the solder mask. I'll just solder on top of it and hope for the best, huh? Why not? Who cares? Powered MULT. Yeah, the file is just going to be kind of annoying here. The other way to do it would be to cut it, remove it, and cut it again. Or cut it, remove it, and file it very carefully so the pins are sunken into those recesses. That's probably how I'll do the next one. We'll just file it after the fact, or before the fact, rather. Another thing I dislike about these is they don't have a dot for pin 1. Instead, oh, what was that? Incredimike, thank you for the 23 months. Hey, I appreciate the sub. I hope I didn't bully you into it from running ads, because I hate myself for that. So this is going right on top of it, and it's right, the pins are located right at the epoxy body of the actual chip. So I think, even though they'll be displaced a little bit, I think we can still get this soldered in just fine, and it'll make all the connections it needs to. So let's see if that works. Now I could show off, because I got all those soldering iron tips in, I could show off the drag soldering blade, but I don't know if I want to do that. Drag soldering's awesome. It's when you put on a bra and you, no. I wear high heels, skipping jump, suspenders, and a bra. On Wednesdays I'd go shopping, just like my dear mama. Okay, try to get that in there. Continue with drag soldering. Drag soldering is when you add a bunch of flux and you load, there's a dog hair on the end of the iron. It's disgusting. Ad break started. Why are these not getting hot? I'm getting really pissed off at my own tools. And a good artisan always blames their tools. That's a picture of Willow. So what I was saying, drag soldering, and you know what? Fine. We'll try the new one. This is for the paying members only and those on YouTube. This is why they didn't want us to dual cast. Because when you run an ad, it only runs on Twitch. It does not run on YouTube. So the YouTubers and the people, I should say this before the ad, but the people on YouTube don't see the ads. So those of you on Twitch, if you look up at @OO_bother capital VOD, you can check out the stream without ads. Wait, how'd you hear me? How'd you hear that? Wait, how'd you know that? How'd you hear that? Wait. So if I load this up with solder, it is already kind of loaded up with solder. And I don't know if this will work really great for an SO8. I think I need my big solder for this because it'll use up a lot. It actually doesn't need to be that much. I'm going to clean that off a little bit. Cleaning off is just wiping it on like a brass pad. But with this big blade soldering iron, I can load that up and then come in here with flux. I heard nothing. I was just watching an ad for AI. It was an ad for AI. Load these with flux. Just do a little line of flux going down this way. And when I put the wedge iron down on them like this, just from the side, just like doot, 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 it will drag solder the entire row. That's not enough solder. I want a little bit more than that. So I'm going to load a little bit more up on the side here. And I'm putting one finger, an extra finger on the iron to make kind of like a tripod with my hands, just so that everybody's nice and stable. SOIC is very forgiving for this technique. And that's drag soldering. It is very clean. I usually individual solder because I didn't have this tip. I didn't buy this tip in previous iterations of these builds. So now that I have it, I can use it. Is this whole thing is pushed to the left, isn't it? It looks like it is. Ugh. Drat. I'm not going to come back with hot air because the socket is already in there. Oop, I heard a click, and then a couple seconds later, 8 seconds later, we get a green light, which means, sorry, you guys aren't seeing it. I literally have a green light next to me. That's my indicator that everybody has come back cleanly from the ad. Welcome back, everybody. I was showing off drag soldering. So we have a chisel tip, we have a ton of flux, and what we do is we just load this sucker up with solder, right? We put a big old blob of solder on it, and then we rely on surface tension as we drag the tip across all of these points, and they just automatically solder themselves. This works really forgivingly with SOIC. When you get into smaller stuff, it gets a little bit more annoying. And our chip is, of course, a little bit off to the side just because of perspective, the parallax of the actual camera deceiving me. This is a little too much solder. I overdid it on that, but whatever. This is a prototype. Glad I came back. Look at that tip. Yeah, it's just designed to overwhelm with solder. Now, if I was a little bit more conservative with the amount of solder, it would look much cleaner and be a little bit better. But this chip is also kind of pushed up by the 2 pins beneath it. So it's a bit of like an illegal move that I've done here in installing it like this. We're sitting pretty though. It seems okay. I'm gonna have to get better at that with subsequent solderings. And I'm keeping the chisel on because we're moving over to the other jack that I've got to install. That's the ground wire of the Donkey Kong connector. So I could potentially come back here with hot air and maybe clean this up a little bit more, but not this side. These are kind of, actually, maybe I can do that with a big chisel tip. Chisel tip to the rescue, huh? It's going to remove this. It's going to remove the component. No, that's not going to fix it. That's just going to remove it. Oh, what the heck? It's like all the way up there? Okay, hold on. We can fix that. Come on, buddy. You can do it. You can do it. Oh my God, my dog is in attack mode right now. You guys can sometimes hear her. That's the problem with that, is that sometimes the iron will pull away the whole component. So you got to be careful with that. That's a surface tension issue. That's a lot cleaner than it was, though. I can live with that. Solder tweezers do exist. Pace sells them. They're like $600. They're expensive, and I've never seen a tech lab with them where they weren't covered in dust. So while they seem like they're awesome, and they probably are pretty good, it's really only for reworking two-pin components, and there's plenty of other techniques that you can use in order to do that, and I just never see people using them. So I think in order to make this flatter, what I'm going to do, I had a second jack that was sitting around on the table. I'm going to grab it once I see it. Where did you go? Some components didn't make it back into the didn't make it back into the bins, and so they've been kind of hanging out on the desk. So I'm just going to take advantage of that and grab this one. This one goes in with this chip here. And while it might be centered, those pins are huge in comparison to the profile of the chip. So flush cutters, cut these completely flush. Nice and flat against the board. There's still dimensions to the flush cutters though. So that's not as flush as I'd like it to be, but it's a start. And so I can actually take that with a file and just file them down a little bit. I watch computer booter solder two caps next to each other at once with one normal pair of tweezers and one iron. It was mesmerizing. Yeah, I mean, look, if my stream was much more successful than not, which it is not, maybe I'd have the budget to get some of those tweezers, but everybody always suggests the tweezers, and nobody has ever seen them in use in a shop, and it, like, every single time, because again, I came from, you know, professional place, and their tweezers did nothing but collect dust. Nobody ever used them. And even though I'd be doing that kind of work a lot, the other techniques are fine. All right, so a little bit of that, we'll see. Oh, with normal tweezers. Came with normal tweezers and a regular iron. Yeah, if you hop from pin to pin to pin to pin to pin, and there's no big ground plane to suck up all of your heat, you can get really good with that and actually remove the components pretty easily without changing the tip of your iron, which is annoying to do. Okay, those should be pretty flush. Let's see if they are. Where I see flesh. There we go. Yeah, it pokes up a little bit. I could keep going just a little further. And go just a little bit further. Now you'll notice that when I'm filing this thing, I'm going back and forth. The hardcore fileists, which, geez Louise, do you not want to be called that, will say that this is wrong. That files work in one direction, and while they do, going in the opposite direction over as soft a metal as is presented in electronics is not that big of a deal. I'm not dulling my file by going backwards over this really crappy metal that they use on things, on components. It's not a big deal. So going back and forth just means that I'm able to file a little quicker. Okay, so let's see how that does. Which socket were you? This one? No, this one. All the way up here. There we go. That's what I'm looking for. Okay, cool. So, these aren't the best at this, but they can do it. Clamp all the way to the other side of the thonk and just press in. Although the thonks can tend to like get a little out of whack, and that makes your design look out of whack, or anything but out of whack. How dare you say that about me? I'm in whack. Use the big solder for these because you want to get a ton in there. Oh, right, I've got the blade tip on. This thing's Neanderthalic. This is a big blunt weapon. Yeah, I wanted to use a smaller solder with that. Hello? There we go. See that how it sucks into the solder thing there is where it's actually propagating onto the big piece of metal that makes up that pin. Thonky Kongs are not that well made, so that can tend to like distort the plastic bottom of this thing and kind of melt the component a little bit. This should be pretty well held in place. So we can get this other pin, yeah, just push it up from below just to make sure there's no gap. And is that relatively centered in the, yeah, it's good enough. This tip is crazy big. This is one of the ones that like I used to use, and then I didn't order one with the when I bought this station both times. I didn't get one. Back when they were really easy to get, I had to place a $100 order at Pace in order to buy these tips. But I can't really function without the big tip. Even the big wedge and the big tip are really important for the techniques that I use. All right, that looks pretty flat. That looks nice and flat to the board. This will go well. Okay, so anchor pin, and we're observing that pin 1 is facing downwards now. Let me get another, yeah, move the ducks. You know, these clamps are pretty good. The only thing that I really would criticize them on is the fact that they make me work a lot higher up from the board. Grind it if it's not flat. I don't really like the grinding with the triangle file is damaging. It would damage the sides of the board. Grinding it flat with like a jig, if I had like other circuit boards that I could put down, that would help me grind it nice and flat. You know, put Captain tape on the side boards so that you have the width of the Captain tape holding you up, and then you can file until it's nice and flat. That would be one way to go about it, but just cutting the pins and then filing them down gives me a nice flat surface. Yeah, angle grinder would be a way to do it. All right, so pin 1 is on the other side, or like this. I really hate this kind of thing. I think this is cheap and lazy. The angled side of the IC body, it makes it a little bit more confusing about where pin 1 is. The good chips will have a little dot on pin 1. I appreciate that much better. And then it just jettisons. But I bought the cheap parts. I bought the cheap parts in volume just so I'd have plenty of TL074. So I did this to myself. With DigiKey, you don't really know what the chip's going to look like when you buy it. And this will probably function just the same as any old. Plus, it's only a powered MULT. My hands are shaking. I can't stand. Okay, hold on. We can reposition my hands. Once I learn how to use these things that float the board so high above everything else, we'll be in better shape. But for now, I'm still learning techniques with thin boards. With the larger eurorack modules, I was making it look like it was easy. But with this little one, I can't get far enough out. Like maybe if I do this, I'll just add something for my hand to brace against. That doesn't really work. It's not far enough away. I need to twist myself. It's all improv. What's everybody else up to? What's going on this Thursday? Come up on top of it and then push it down. And that's going to get it as flat as it'll go with my two little blobs there and there. That looks pretty good, actually. I think I got that one nicely. Trying to fix a USB soldering iron. Ooh. How do you get wattage out of that? All right, this is starting to displace all the junk on the board. Wait, what's going on with those pins? Why is this solder down there? Since when did those pins solder? That's weird. For tiny things, yeah, I would imagine. USB, I don't know if that has the punch. All right, we're gonna do drag soldering again, just because I just bought this nice wedge tip. So I go through and I just basically drop of the flux. The flux is going to make that solder react with surface tension much better. It'll stay hot longer, and that'll allow it to retract back into the pin. And then a little bit of solder on the wedge, and then I'm going to do my extra finger on this thing just for stability purposes. we should be able to just go down the line like this. That's somewhat working, but there's some small problems. And those mainly stemming from the chip is probably sitting up from the board a little bit. So I'm going to load up a little bit more solder on that side of the wedge. Try that again. You do want to be able to see the pin a little bit, like on the professional soldering jobs. I tend to overload, which is what's going on right now. Let's see if we can get this to distribute a little better. My angles are all messed up. No, some of them can be if you get certain kinds of flux, but flux is relatively cheap. I need to look for more flux because they're starting to run out. These have too much solder. I may come back and fix those, make them look a little cleaner. Because yeah, that's definitely way too loaded up. USB-C. Oh, it was C this whole time? If it was USB-C, then yeah, it's got plenty of power. Those Pine Sill and TS80 and 100s use TS80, I think, uses USB-C. I thought that would be a good iron to travel with because you can bring a battery bank and you can have a 200-something watt soldering iron, which is just 100 watts below what I'm using right now. Huh, fascinating. That didn't work at all. Or it worked really well, and I don't know. No, it's not. So the solder's not getting down to the pad. Yeah, see, I want to see that whole pad flow over when I do that. I think that got it. I think they're soldered. Let's just check from the side. Yeah, I don't know how big your battery bank would have to be to support that kind of power. That is floating. That is a floating pin because this isn't sitting flat. Because you are floating. Now, let's see here. Can I push with the tweezers? Get us to sit a little flatter. Or, in lieu of all that, maybe I just load that one up with solder just so that it's a big blob and it makes contact because there's a pin sitting below it pushing it up. Yeah, that's the solution. So it's sloppy, but it works. It does what it does. If he dies, he dies. Okay, so that's the chips and a little foyer into drag soldering. Those had to be done in a particular order just because that's what I designed. The next thing that has to be done in a particular order is the power plug, which sits going this way, but it's got pins coming up in the other direction. You can do all kinds of weird stuff. You can cut these so that they fit. Thing is, FunkyCon, that connector is going to be sitting right there. My power pins are going to be right next to it. I think what I'm going to do is get a header and then I'm going to cut short the pins. I could use that red header and then this thing would look like McDonald's color scheme. The yellow pin header. This one isn't big enough. Oh my God, I'm going to do it. I'm going to do it. I'm loving it. Ba-da-ba-ba. Oh, I got sued. I got sued. You guys got me sued by saying that in chat. Yep, this is your fault. Okay, so when soldering pin headers, it helps to plug them into something. So I have these big ancient female headers. FBI, get down. Just crashes and shooting noises. So I'll plug it into this and then hold on to this with a clamp. And that will allow me to wiggle everything around and get this soldered in orthogonally or whatever, parallel. So basically what I'll do is solder it like that. But what I want to do first is actually cut these pins so that they don't stick out beyond the pads. Oh my God, put your finger on the flush cutters so it doesn't send a pin into orbit, shorts out your power supply and your computer, blows up your RAM, costing millions of dollars in computer replacement parts. A good pair of flush cutters will get you far. If you're going to be building a lot of boards, Nipex. If you're not, then the cheapo ones are just fine. It's just after a little while, one of the arms of the flush cutters is going to literally fall off. And it might not be in a year, it might not be in 10 years, but I'm really enjoying this stream. It's soothing to watch. What, when fucking ICE breaks down the door on behalf of McDonald's and shoves me into a van? You're sick. You're disgusting. Why would you think about that? That's awful. All right, I gotta file these down. This has been just like a chill soldering stream, and I do appreciate these. We're gonna do like some module testing and stuff too, so it might actually remain chill for a couple days around here until I get back to the mechanical stuff of making the big simulator setup. Yeah, or into your eyeball. That would also be a bad place for these to end up, the little cut ends. So I kind of put my finger on it, but if it's a strong enough metal, it'll actually rock it into your finger hard enough to that like it hurts. And these can get kind of sharp if you're messing around with them like I am. Why does it always come down to me filing stuff? It's the least visual thing that I can do on stream. But yeah, here I am, filing forever. All right, let's see if that's flat to the board. Flat to the board. I try to be a little bit loud just so that we're not a totally boring stream, but these solder asthma streams seem to be the most boring. Yeah, I could be filing folders. That would be worse. That does need work. First two pins. Those might not contact anything, the first two. Yeah, because they're square in the middle of this, but I just want to make sure, and then I want to put a piece of Captain Tape down on top of this because these Thonky Kongs are notorious. Where's the second one? Oh, we already installed it. I need to show you guys a Thonky carcass. These things are notorious. If you have pads that are around the Thonky Kong connector, you got to be careful because they've got metal bars sitting inside of them. And although there is a little bit of a gap there on the official ones, I don't trust that at all. So I'm going to put a piece of Captain Tape down on top of these pins just to make sure that they don't contact with anything. But I got to file this side first. Can you file fast enough that it shows on the thermal camera? I don't think so. Because the file's metal, it's going to be dissipating all that heat. This is boring. I wish I didn't have to do it. Get the Dremel in here with one of those bits. Nah, that's not necessary. I would like these to be recessed a little bit, but I don't know if I'll be able to achieve such things, such feats. My fingers are warmer than the file. Yeah, they'll eventually heat the file up enough. I mean, you know, using power tools, of course, you see all the heat get into everything and the friction and all that fun stuff. Those are pretty much below the level, so we can solder them in, and hopefully they don't go above the level. Stay below the level. Below the level. Above the level. Wedge tip, I don't think so, man. You gotta sit this one out. It's been real seeing you do stuff, but we need to go back to our slightly more manageable. Now the wedge with the extra power supply on it used to be our jam. What's up, Plush Master? Okay, big solder, big iron. Wait, we don't need the one with a heater. What am I doing? These extra heaters are how you utilize the full wattage of the soldering iron, but we don't need to do that. We don't have big power traces that we're dealing with. We're just dealing with normal power traces. This is a powered multi, which means that a powered MULT, which means you can plug in multiple things to it, and whatever signals are going in, it will repeat and pass down the way. There's a couple weird things that we've had to do to assemble it because I've taken full advantage of the 2 HP form factor size, and I have things on top of things that are not supposed to go on top of things. What the? That was a lot of solder. I was thinking I'd have to desolder it, but it seems to have absorbed it. Okay, now heat that up and rearrange it so that it's flat. Let's see where I messed up. Looking good. How crooked is that? Only a little bit. We can correct that. Okay, so what the? What? That one just got filed a whole lot. Weird. Weird. I'm Bostonian. I'm not from Boston. I'm in Philly. All right, let's get some solder on these. Be done with it for once. I want to make sure that I hold heat in here for a little bit, just so that the solder sucks all the way in, leaving us as flat as possible in the end, because it'll go way down in there into the via. See, now that's nice and flat, a little bit convex. So just hold the heat in, let it pull this thing through to the whole via. That's why we're using the big tip, so that we can get plenty of heat into these ground connections. That was too much solder. I might have to pull a little solder out of there. I pre-cut the leads and then I filed them down, because when you pre-cut them, they don't get quite low enough. They stick up a little bit. That was too much solder in that one. Come on, bud, you can do it. All right, let's see how we did. Debating about whether or not I want to put the piece of Captain tape down. Those look decent, flat, good end. Okay, I think that'll be good. I think that'll work. Let's just see here. I'm wondering if I need to put down Captain tape, because it'll make this plug-in. Oh, that one's. I keep picking up the wrong ones in this bin, probably because I'm using up all the good ones. I think I need to do another thonk order, which would be another 6 billion connectors. Oh, well, for resistors and capacitors, they're all surface mount, so they don't have leads. Generally, you do not pre-cut. The reason I'm pre-cutting is because I have a through-hole component that's going on top of another through-hole component, and that's generally frowned upon. It's not a thing you would do. But I've done it because we don't have any space on this board for components. The powered MULT is using every little iota of space that I have available to me. And this is the power plug. That works just as long as it's not contacting anything that shouldn't. The bar there might be grounding. Is that the part that... That's not, so that's the switched pin. So that would be connected to the output with ground when nothing is plugged into it. But when something's plugged in, it would pull away, and these are both ground pins. So it's actually not a big deal if I don't put down Captain tape. Ooh, spicy. Here, what I'll do is I'll plug this in without soldering it, and we'll see if we're contacting ground on that output pin. if I just press this together. If I solder it and I don't apply heat for like a ton of time, it shouldn't connect. But if it just presses together and connects, then that's a fail state. Maybe. Move it around. All right, so actually that little lip is preventing us from contacting. So I might rescind my judgment on whether or not I should put captain tape down. Gotta make better contact. Yeah, so that's not really, I would see ohms if that thing was contacting. So I think I'm good. I don't think I need to put down tape. Tested it, it doesn't seem to need tape. There's a little lip. Yeah, there you go. A little lip of plastic that's saving us from contacting on the board. How much do I trust that? I don't know. I don't know, because it's pretty close. I think we're good for now. We'll just remember that in case we run into problems. Okay, so we've gotten much of the stuff installed. We have both of the chips are installed, although it looks like a baby did it. It doesn't look, it's not quite up to my standards. We got all the 0.1 UF capacitors. We got all the LEDs. We've got our pin header for power input, which is a little crooked, but I'm not going to let that bother me. We need to install all of the resistors and the capacitors. And as we saw earlier, I'm not quite sure what I want to do with the R's and the C's. I put in 2 tantalum capacitors. They're kind of sensitive. I don't know if I need, well, I don't necessarily need them, but maybe we should put some tantalum capacitors in there. I have a kit of tants that are 35 volt sensitive. Tantalum capacitors are expensive. They're boutique, they're nice. You don't really generally use them in designs that aren't like equipment, like research equipment. But I've opted to put them in here because I was pressed for space. Probably should have put in like the big 10 microfarads, like the big guys on this, but a MULT, it's a multi tap. So you put an input into one of the ends and it'll broadcast it on 2 banks of 3. And if you put 2 inputs in the 2 inputs, then each input broadcasts it on 1 bank of 3. And so that will allow you to power all kind of, will send your signal to multiple different places. Where do they come up with these terms? How do they do that? There we go. These are 25 volts. Can't use 6 or 10. 16... No, 25 is really the only. Wow, there's only 135, 225. Okay, we'll take a look at what. I think I have a second thing of tantalums. Well, let's just see if we can find one in here. And push comes to shove, maybe I find a regular electrolytic capacitor to go in these. We'll just use the same pads. Where the big, oh yeah, this big kit that I have. If maybe the smallest size fits. We'll check that in just a sec. I don't feel comfortable putting something that's only sensitive to the, only tolerant of the 12 volts difference from ground to whatever the voltage is, when we have a system that goes plus minus 12 volts. If it goes plus minus 12 volts, there's a chance, although it would be a disaster, that it could see 24 volts. So that's why we pick 50 volt capacitors. You don't want it to be exactly at the voltage. So I'm looking for B-type 225. .35 volt 225 225V is written on it. Now, if I wanted it to be a signal multiplier, that would actually be very easy for me to do. I just install 2 100 ohm. Oh, there it is, 35 volt 225. That will fit. That'll fit. So let's take a look at these other ones, these electrolytic capacitors. These are surface mount electrolytic capacitors. They're a little bit more compact than their through-hole equivalents. Here's 10 UF through-holes. That's the size of that. If we look at 10 UF, it's micro, it's 10 microfarad, but we just say UF. 16 volt, 25 volt, 10 UF is right there. That's the size of a 16 volt, 10 UF. This one's 25 volts. Wait, where's it? 35 volt, 10 UF. A little bit larger, but still a fraction of the size of the through-hole equivalent. So let's see, what's the happy hap here? 1 UF is 4.750 volt would be nice. Does this not open? Okay, it opens. It opens. No, I don't think I'd be able to get to the ends. I could barely solder this in. That might barely fit. So we can have 4.7s. What are these? These are 225. What does that stand for? That value means something. I think it's 2.2 UF, or is it 22 UF? So should I use the tantalum or go with the... I'm going to go with the cheap one. Tantalums are not worth it a lot of the time. They're also very sensitive. If you overvolt them, they blow up. Nice and easy, which could be great for the stream, but at the same time, I'm just going to put in... because these are also 50 volt caps, so... Are you building it for some specific use? Yeah, for a eurorack, a modular synthesizer. So the purpose of the MULT is so that I can send all kinds of different signals to multiple locations. And it's a nice, easy circuit to build. It was a good little win to clock up for the stream. I like getting my little wins in. 50 volt, 4.7. 16 volt, 10. Okay, 54.7. We got to make sure that one is larger. Wait a second. Yeah. Coming from Unethical Clown. It's no wonder Unethical Clown wants explosions on stream. It's so predictable. 10 UF. That one's 4.7. We don't want the 10 UF. Those are 16 volt. That, while tolerant of the voltages, is out of spec. I just don't want an explosion. Is 4.7 going to be enough? I think it'll be okay. And it's also pretty big to solder in right now. But we'll do it anyway. So, the stripe on these denotes negative. And will this be forgiving enough for me to get this onto these pads? Oh, barely, because these run under the cap body. Whoever decided to design the cap bodies like this is evil, and they should be punished. It's really quite awful. These are the opposite. The tantalums, don't the tantalums mark plus? So this actually needs to be the other way around. Because the more negative goes to V minus, which is where this is going. This is going all the way down here. Wait, no. Yeah, there's the stripe. The stripe denotes minus. So this is minus. The diode is facing, the arrow is pointing towards minus from ground. And so the more negative is on this side. So yeah, the little taper in the front is our other indicator. So we get this soldered on like this, and it's going to be the single most frustrating thing to solder on because the way the legs are operated on these. I guess, I could try to do it with hot air, but it's kind of annoying too. And actually, is that going to get in the way of... No, it's not. That'll be away from our power plug. Why is that moving so much? It's loosened. Let me get a different duck on that. Duck and more duck. Okay. That's going to be so annoying to solder. I've done it before. What I'm doing right now is I am avoiding figuring out what value components to use in order to get a non-inverting unity gain amplifier design. I think the answer is 0 ohms, but hey, guess what? You can no longer access the pin. Oops. No, no, I can't get there. Please come back to me. Please. Please? Oh, we're like floating way above it. Yep, I'm melting it. I'm melting it. It's doing horrible. Terrible, horrible things are being done to the capacitors right now. Maybe I do want to put the tantalum on there. Yeah, I kind of made myself an access hole over here, but I think I've completely ruined this cap. I think I've melted it to shit. Well, I guess that kind of put it on there, and I see a little bit of copper on the other end, so maybe I'll get away with all of my sins today. No, no, these are too big. No, they don't fit. Look at that. No, that's going to block it. All right, no, no, scrapped it. Scrapping it. Scrapping it. Scrapping it. The weight of our sins is too great. Back to the tantalums. We'll put the tants in here. Yeah, it's pure evil. Also, it's good to have pads that support that socket, and I didn't, so... So we're going back to the tants, because that was what the size that was originally meant to go there. Put these back and have just the the mangled one be in with the others. Which bin did it go? This one. Got a new set of those. Okay, now we gotta find it again. So it was 225, yeah, 225. I think it's 22F. 225, where are you? Let's get these out of the bag. Number 101. 225, huh, found it immediately. How did that happen every time? That's 35 volts, so that's over the specification of 25 that this thing could potentially see. So it should be safe. We get 22 microfarads and a lighter wallet. These can get took out by stuff pretty easily. Like a reverse voltage can take out your tantalums nice and easy. Okay, 2U, dropping in. Come on. I'm kind of excited about this. This has been a nice project. It's an easy circuit. It's pretty malleable depending on how we want to actually populate everything, and it went together nicely. It looks good. It's got a McDonald's color scheme though. I didn't anticipate that. Now with the tantalums, that stripe is actually plus. They're pure evil. I don't know why they do it that way. Let's double check before I do that. Double check before I actually solder it. Let's double check. Look it up. We're not above that. We don't need anything to validate us. Tantalum capacitor markings. Images. So the tants are just annoying. Their plus side is the stripe. Why they did this when everything else was the other way is beyond my ability to reason. Boy, those markings came in weird, didn't they? Twitch TVO bother and stuff. See, okay, what happened was, as soon as I grabbed it, this thing tilted upwards. little crooked. I think these are also particularly sensitive to heat. You gotta be careful. I use this special capacitor in a power supply that I built once. That was a Panasonic like multi-layer, but it was plastic. So it just detonated. What are you doing? Hand shaking uncontrollably. Okay, so push down here. Oh, see, that wasn't so bad now, was it? Jeez. It's a little crooked. I'm gonna leave it. Where's my other tant? It's all the way down here. My tant! You punched me in my tant. Go, and you ease on in. Nope. Come on. Big traces back here. That's what makes it tough. A little bit of flux wouldn't go unnoticed, or maybe just a little bit more solder. But if this is enough to hold it in place, that's all I need. As long as it's sitting, it's not sitting flat. It is rearing up like a horse. Why are you rearing like a horse? What are you? You're a capacitor. Like a glove. There you go. All right, so now we can solder the other end. Oh, and in 2 minutes. 2 minutes. Yeah, the tantalums are nice. You get like a lot of capacitance out of the tantalums for a very small area. They're big boxes. They're easy to solder, but they're sensitive and expensive, just like I am. Sensitive and expensive. So you got to treat them right. Otherwise, they'll blow up on you. We're 2 minutes before an ad, and I just will be waffling about. I'm not going to do much, but I am going to continue to build this circuit. And of course, being that this is homemade circuitry, all of the stuff in it is going to be a little bit crooked, and that's okay, because this is our prototype. On the later versions, I can worry about more professional assembly and coming up with techniques that'll put this thing together a little bit more cleanly. Obviously, one day, we will be able to use a manual pick and place to put all the components down and then run things through a little oven or a hot plate. But for now, may your caps be wobbly and your resistors slightly misplaced. Do I want to try for hot air on that? Nah, let's just leave them where they are. Not blowing up would be considered a success. Got about 1 minute and 30 seconds until we do an ad break. It'll be a 3-minute ad break. In the future, I'm going to try to run a couple ad breaks during the intro, because I think that'll be a good place to kind of burn a few, and that way they'll be more sparse in our schedule. They seem to allow me for additional time between ads, but it's like, if we were playing a video game, that would be fine, but sometimes I run out of stuff to do. So running like a certain level of ads is, I don't know, it's weird. Not the ads. Yeah, you get ads. You all got ads. Or you get a bump down in quality for the ad. I run those scripts too. I know what they're like. The weird thing was, though, on a particular streamer's stream, one that rhymes with the F word, the ad breaks would cause audio to like get choppy. It was very weird. 7 streams streaking. Somebody get some pants on that guy. Close this. We don't need to know about tantalum capacitors. What's wrong with you? TL074 unity gain multi. Try that. It's all, the Reddit one is the one, and that's what I wish I could see, so I knew some component values. I own over 40 pairs of jeans. That's a significant amount of jeans. Oh, hot air station's still on. I'm going to turn that off. We got 2 minutes on the ad. What the hell values am I using for this thing? I think there was another post inside of that Reddit thread, because there was one that put us over to this article, but then there was another one with the designs and stuff, and then I don't know, somewhere there was discussion about the LED circuit, and this was sort of the conclusion to the LED circuit discussion. I don't know what the values are for any of this stuff, because I glossed over the design. I said, okay, we'll figure that out when it comes to actually choosing components. And it comes to actually choosing components now. I gotta figure out what these two are. Okay, so what are we using? Let's see. Just bought another pair of jeans. I buy a pair of jeans and then I use them until they blow up. And back when I was in the days of, what was it? What was that store called? There's a store in the mall that just had a bunch of like decently priced clothing. But it was like the holdovers from another like more fashionable place. But all the stitching on them was terrible. And so eventually what I did is went to Duluth, and they sell jeans for people who work in jeans. And so those have like triple stitching on everything. And, you know, they hold up really well to the types of abuse that sitting in a stool from the 1960s can give you. I don't know if this is particularly stressful for a pair of jeans, but, you know, these do last. Problem is my waist is too big and my legs are too averagely short. So the size that I have, I got to roll up the pant legs in order to make them fit. One day I will be a normal human shape. So that's specifically for the LMH 6611. I think I found a mutables design that had what I was looking for in it. It might have been one of the ones that I already have. No, you know, I don't think it was one of the ones I already have. And the mutables that I had open were different. And then this one too. This was another one. A 1K, 100K, nothing to ground. Nothing to ground. And this is non-inverting because our signal's going into plus. So if I do 100, 0, I think maybe that's the play. I included a resistor to ground, I guess, in case I wanted to have it be attenuating a little bit. But we don't need to put anything in there. That can be an infinity. And then down here, although I don't have a resistor to ground on this signal. All right, so we're back in just a second. I'm waiting for my, green light. Okay, green light lights up. Welcome back, everybody. Okay, so we're deciding what value components we're putting in R1 and R2. And these are determining what the transfer function of the amplifier is going to be. R2 might not be included in this design. I might not have needed to put in R2. That could have really saved me a lot of space. Damn, I did not go over the circuit enough. Holy sh! I just lost, did I really lose 20 viewers in an ad? It'll bounce back up, it's an anomaly. That or, I don't know, somebody went live. Who's cooler than me? R1 being the feedback resistor, I feel like I need something there. It can't just be a short circuit, because then when would the capacitor ever do anything? But it's like in many of the designs that is just a, although it would go through, it would bypass R3, so maybe it would still do something if it was just a short. Clarence Wiggleheimer with a 3-stream streak. Welcome, welcome. Yeah, so accordion to this thing. Oh no, according to Discord discussion, this was the simulated circuit for one of these. 1 nanofarad, huh? Well, actually, these are the components that I have. 100K, 1K, and 1N. Do I have 100 kilo ohm resistors still? I think I do. I think I ordered a bunch of them at some point, and that's probably one of these big reams of resistors that are sitting around here, and then I lost track of them. So, but I also have them in my thingy wingy in the books. don't want to use up all my 100Ks, but I guess that's just where we're at. So the R that goes all the way back from feedback. So that's going to be 100 kilo ohm resistors. I'm holding down control. Oh, damn it. Okay, so that group is 100Ks. For the LEDs, I'm not sure what those get. We'll come back to them. If I go to the 2D design, it'll highlight all of the resistors that are going to be 100s. So it's sort of the middle resistor of these rows. This is viewed from the front. If I want to view the other side, I can hit F to flip. And now I'm viewing it from the other side, so now I know which ones in the view that I'm going to be seeing I'm replacing. If I really don't want to confuse myself, there goes the top layer of copper. Now I'm only seeing the bottom layer of copper, so I know what structures I'm looking for in order to place these components. So I took all the labeling off of the board because it's so small. There's no point. I can't fit it anywhere in there, so let's get this built up. So we're up here. This is upside down. We're walking. Okay, so we're here. There's version 1.0. My text is very blurred. My chef's hat does still look like a chef's hat. I don't know what you guys are seeing. That is a chef's hat. But so the resistor that I want is this one right here. Oh my God, really? That's the feedback? Oh, geez. Okay, all right. All my pretty lines. Oh wait, we need to find the 100Ks too. 0603 resistor. Did I have like a stash of 100 somewhere? I don't think I did. These were both capacitors. 10F, yeah, those are caps. Okay, so 100K. Where are those? They're somewhere in this. I've got these books that are these little folders that have cut tape samples of capacitors or of components on them. They're very, very nice. They're very useful. Yeah, it looks like I ordered 100Ks and then I refreshed my supply, and I need 6 of them. So I'm actually going to drop them into the bin, this little bin that I have. 1, 2, 3, 4, 5, 6. All right, there we go. That goes back into the sleeve. I'm going to be retiring this book because I actually just spent, these are like $40, so you just toss the old one when it starts to deplete. Is it a flying chef's hat? Yeah, those are motion lines. Those are motion lines coming off of the chef's hat. Then up we go. Oh, these are coded. When you order extra resistors, you never know if they're going to be... Please get off of my tweezers. Thank you. You never know if they're going to be a value written on them or if it's going to be a value code. I hate the codes because you have to look stuff up in order to know what they are. Hate them. But the value ones I love. You just can never predict. Please. Jeez. Position my reel. Where are we? There we are. Boy, this is not used to it. It's so much more restrictive in the view. Make sure I'm on the right component. It's a chef's hat. That's a capacitor. That is a much smaller pad for the capacitor. Why did I accept that? What was I thinking? That is so small. Okay, so well... Like, how dumb am I? Ah, damn it. The stray solder hit the side of the iron and just like cut itself off. Yeah, see, these are like super easy pads. That's how I redesigned all of my resistors like this, and I guess I didn't hit the capacitor with the love that it deserves, so the cap is like extra small. Might even be 0402. I didn't check myself over on that. There's always something that you forget on a circuit board design. And in this case, those caps are a little bit restrictive. But that's not a showstopper. We can get around that. All right, so that one, and we're at the bottom of this stuff, so you guys got to move out of the way. Let's just get this up here. Look over on CAD. And it's those two. So the symmetrical, I kind of tried to make the design as symmetrical as I could manage, cutting and pasting stuff. Oh, they have to put their own part number on it, and that's what that number is right there. I did not choose to put that on the board. Sometimes you can do like a frame around your design, and then you'll have them put the number on that frame, and so that'll break away. If I did do a front panel along with this panel, I could have done that. Grab another 100. Okay, or just ghost grab it. These components are very small. I mean, this is not a hard build, but it's taken a little while just because I got you guys in tow. I hear dog communication going on. Why is this not? Oh, there it goes. It actually did while I wasn't paying attention. Oh, there's something yappy out there. I hear yapping instead of barking. I wonder who it could be. Yeah, so this design could have been way cleaner if I had actually figured out what the values of the components would be, which were not going to be, whatchamacallit. Like, I don't need an entire component. It's this resistor here doesn't need to be there. Could have been cleaner. Okay, now we get the other side of the chip, which flipping the board over would be a great way to do this, but I'm just going to try to kind of get in there at an angle with the iron. Good enough. Ah, jeez. I really dislike when it does that. It just beads up next to the iron. This is a little bulbous, but I'm okay with it. This one doesn't really look soldered. That one looks perfect, kind of. I would like to have solder all the way on the top of that one, but close enough. So let's just do that there. And then we'll do the same thing over here, just for peace of mind, because sometimes the anchoring can cold weld, and that one overdid it. Whatever. Okay, it's good enough. Next cluster. That would be only the one, is the 100K. Just this one. Double check. With CAD. Yoink. Yoink. That's correct. Get another 100K out of the bin. I can see that far away. I really could use magnification on that bin. I've been using this solder reel to hold up my soldering iron arm, and it's just the right height. JRH NBN. Crap. Why did I do that? It's a little off. It's a little off. Perfect. The other end. It's kind of a weird way of doing it, but We'll keep doing it. Okay, that's textbook, man. That looks professional. That looks pro. Now it's just these two that are right below the cap. That's a little too much, but it's fine. It's fine. Yeah, these are hand solderable. They're not manufacturing sized. But it didn't occur to me when I was looking at the circuit, the design rather, that might be a little small for those caps. Where's the other one? Man, getting these out of the bin, you realize how small this crap is. This stuff is small. Tiny, tiny. Can't really even get it. It's so small. Go. And you got to be really careful with how much pressure you put into the tweezers. That's why it's good to have tweezers that you really know well, that aren't super springy. Because if you put too much pressure on these, it will make a little click noise as it flies into the upper atmosphere, and you'll never see it again. It'll fly across entire tables, and these things are small enough that you just will not find them. Yeah, see, with the wider pads, this is so much easier. 0603 is a struggle, but it's a I don't know, it's a worthy struggle. Your designs can be much cleaner with it. Why are there two components that are missing here? Oh, the other one is a 1K. That's right. Okay. Yeah. Right. Okay, that didn't, no, that's a disaster waiting to happen. Grab this, place this back over here. Really only 30 minutes until another ad? This is getting disgusting, these ads. Soldering these from the opposite side is kind of annoying. Maybe I should go right to left. Okay, that's all the 100Ks. Let's do the 1Ks. The 1Ks are going to be these, I believe. Let's just double check that real quick. The other one goes to ground, and that one we're not installing. That one's infinity. So we're going over here, and we're looking at our 1Ks, which are these. I don't need to highlight all of them. Let's just look for one of them. Did I not click on it? I didn't click on it. Boink. And then we go over here. Yeah, so it is the next one. It's next to the 100. Why are these? Oh, because these are the LEDs and it's got 3 components. Although this could have been 3 and 3. That could have been even. Oh, well. So it's basically these right here. So 1K, we're going back to the book because I don't have 0603s in an open bin, and 0805 sized are too big. So 1 kilo, 1K. Oh, running out of those. In fact, I only have 4 left on this thing, so that's enough for 1.5 of the designs. It's not that I have more. We just have to get the other book out. Right there. Get 2 of them installed. Oh, good. They're on the end of this whole diving board. That's a little unstable. We're going to have 1 kilo ohm resistors flying all over the place if I'm not careful. I need like a second solder spool to put my other hand on, so I can hold my hands up. Ugh, flux, sticky flux. Oh, what's up, Long Dog? We got our first YouTube comment. This is kind of dead YouTube. Cannot look at the comment yet. I'm still maneuvering. Maneuvering my appendages in order to attach a thing to a thing, believe it or not. But I will return to Earth in just a minute. Whoa, freaking out. Okay, there we go. My hand started shaking in the middle of that, and I don't know, just one of my muscles decided not to participate and said, hey, you guys can deal with everything else on your own. I'm out. And so everything just started to go crazy, which happens. Okay, 1, 2, and then you guys are going to the other side. And no, no. And then hit the other side. All that has to happen is a tremor. I mean, that was like something like a tremor. I don't know what that was. Just my muscles deciding that it didn't really want to help anymore. How much caffeine? I have 2 cups of coffee, but it's not, I think I had 1 today. And it wasn't that long before. It was pretty spaced out. What's up, GGA? A little too much soldered on some of these, but I'm going to leave them for now just because this is a prototype. Doesn't need to be perfect. Leave that to manufacturing. All right, so now that that's done, I'm going to clamp in with that, and then we can do this one here. Oh wow, one of them is like perfect. How did I do that? Back from school. Welcome back. Welcome back. We're soldering what's called a powered multi, which basically is a bunch of unity gain. Unity gain meaning the power in or voltage in is the voltage out. There's no amplification at all that goes on. It's 1-to-1. It's multiplied by 1 in the transfer function. So unity gain powered multi, which means you plug in one of your eurorack signals and it comes out the outputs through an amplifier so that you're not diminishing your signal. What's up, Big John? How you doing? How you doing? How you doing? All right, so if we can get the other side of this. This is awkward. Underwater. Are you, wait, are you a submarine? What's going on? Okay, there we go. Is it storming out and I'm unaware? I can't tell. I can't tell. Stop sticking to the when components are sticking to tweezers. We're trying out these duck bill looking circuit board holders, and they're really good, except when they're not. I don't really know what to make of them, because like, okay, that's way in the way. That one just, this one whole, the whole one needs to move. Just get out of there, get out of there, get out of there. I mean, just because I'm being careful about the amount of solder that I'm putting on, it looks like it's going okay. This is bugging me. That doesn't look like it's soldered over here, but I think it's just the lighting. Ugh. Where did that go? Am I going to be able to see where it went from all the way up here? That's an LED. That's not even... What even is that thing? What else do we got? What's this? That's stuck to the thing. That's not it. Here it is. $102. It is the right thing, but it's stuck to the flux on the tweezers. This is the most annoying thing that could possibly happen. Ugh, that is so annoying. I get mad. I know, it just kind of leaves. Boop. Gone. Heat. Heat. There we go. Heat. 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 Hello? Hello? There we go. Okay. That's a little too much solder, but I couldn't really help it. I got excited. Ugh. I grabbed it too far up, but it's now stuck to the tweezers, so I just have to kind of eat it. What did I just see something? The hell? This is scary. In the reflection of the monitor, I just saw something pass by. Oh no, it's on, okay, it's the screen behind me. Okay, there's a monitor behind me, and so something just passed by on the monitor behind me, and that's what I saw in the reflection. I was like, what the fuck? Is there something in here with me? It's like someone is about to like grab me. That's kind of a no-no technique right there. It's Big John's come over and stealthed his way all the way down here with like a white t-shirt on. It's too much. Just grabbing some wick. No, you're not allowed to have, my chem wick is expensive. That stuff costs a lot of money. Yeah, Big John is actually literally up the street from me, so, which is kind of weird. All right, so 1 kilo ohm. No, I don't have any left. 1 kilo ohm versus 1.1. I think I want to go with the values that, you know, I like the real values that I want. So I don't know if I want to go with 1.1. The effective 1.1. Well, that's what we need to determine. So the article for, what are we looking for? R ISO. So RISO. And the effect of it going up or going down. 47, 5, 79, 192. What the hell are these? Wait, what are these values? This is ridiculous. That's not 1K. Everybody else uses 1K. Where did we get 1K? 510. This one's using 1K. Gain of -1, plus 1 volt to the input resistor. R48. Current limiting resistor R48 can be ignored. I mean, it's not like I have more 1Ks. I just have to get the other kit of resistors. I don't know what all these words are. This is essentially what we're building, by the way. Very close to it, although this is inverting. We want to build the non-inverting version, so I don't know if that's actually... I don't know if we're... This might be a problem. The 100K there might be a problem, because what does that do to the what does that do to the transfer function? I might have chosen poor values for this. Because our transfer function VSVE 1 plus R1 over R2. In our case, R1 is 100 and R2 is infinity, which a number over infinity is infinity. It would be 1 plus infinity. I think we're overloading this. I think that's not correct. I think we need but 100K is infinitesimally small. So it would be like 1 over infinity, which is super duper duper tiny. So the 1 plus VE times 1 plus an extremely tiny number means that VS is equal to VE. On a theoretical scale, because we farted an infinity into our equations. So I guess that 100K is fine, and it is in fact giving us unity gain on this. Don't you love math? Yeah, 0.1 or something like that. Well, if I've got that extra, well, it turns out, well, no, the R ISO was not built into that equation. So for R ISO, they've got all kinds of values on it. We went with whatever we found in a random article that doesn't even cover what RISO does. It just says the current limiting resistor R48 can be ignored for the moment. It just forces the op amp to work a little harder. What, in a higher or a lower value? And so we look at an example. Am I smelling rain? Is that what's going on? I think I am. An example that would be an Emily Gillette circuit that actually uses that scheme, which I'm not finding. I guess 510. Although this is a wildly different, there's another example out there, and I'll have to find it at some point. All right, so 1.1 is probably okay. I don't like, so this is the first time building a prototype circuit. I would rather be able to characterize it with the values that are supposed to go in instead of using a smorgasbord of 1.1s and 1s. The difference of 100 ohms that can be significant for something like this, for current limiting of the stuff. But we're probably not going to see it in testing, but then I'm going to build it and Julian's going to plug it in and go, this is a little different, what'd you do? And everything will, it's just every time finds the one flaw. What even fell out there? That's like a cut. No, this one's fine. Okay. So the top circuit is going to have a couple 1.1s instead of 1s on the current limiting element of the circuit. Oh, wait, we wanted this to be down further. Well, it's actually this one and the one below. So if I can grip it like that without it being totally unstable, that'll be good. One of those down there. We're almost there. Yeah, like, look, it might not sound significant in the grand scheme of things, but it can make it so that stuff's a little different coming out of one of the channels. Yeah, we have the original circuit on 3 of the channels of this. 4 of the channels of this. So the other 3 can be 1.1, and we'll see what that does. We're sending the police for that too. Hello? There we go. The worst thing you do is when you look for your iron in the microscope and then send the iron into your hand. I'd like that to be pushed over to the side a little bit more, but I don't have as much control with my hands floating up in the air in the way they are. Using the reel under my soldering iron hand is pretty good. I should probably get 2 like tall wrist rests. And that way I'd be able to have both hands be even with the board as I'm used to. One there, one here. Did I get 3 or did I just get 2 of them out? I think I just got 2 of them out. We'll get the 3rd in just a sec. I'm annoyed that I didn't notice that the capacitor was a different size, because it should be exactly the same with all the others. Okay, let's get this one. Whoa, way too far over. The whole circuit is ruined. Everything goes in the garbage. I lost all my heat. Hold on. Do you know how to know if you're in the path of a tornado while you're in your basement unaware? Are you in your basement waiting to see if you're in the path of a tornado? You need like a radio, bro. Aren't there like weather things for that? Or storm chaser? Man, I don't know, man. We're not on the tornado belt. You hear, what you hear is you hear that industrial noise, which is just the motor. The wee clunk clunk. You know, that stock sound. that they always use. We are now got like 4 alerts in the past month. I guess we have gotten quite a few, huh? All right, so that's all the 1Ks installed, for better or for worse. We need to find capacitors now. 22 picofarad, I think, is the value that these typically use in the Emily Gillette circuits, although we've seen a bunch of different values, and all that is a high-frequency filter to keep things from getting into oscillation. I can't believe we put 1.1Ks instead of 1Ks. That felt dirty. I'm disgusting. I'm disgusted. That was filthy. So we got the 1Ks in there, and we got the 1Ks in here. Okay, yeah, so we're on to capacitors. Don't tell the cops. All right, so capacitors, done. Or resistors, done. Oh, I just bumped the microscope. Hopefully that didn't freeze. If this microscope freezes, I have to close a lot of applications and start them over again, get everything calibrated. Capacitors. So if I look at 22 puff, 11 puff, 15 puff, 22 puff, there's a vast number of them missing because we've been using them in the Emily Gillette circuit. So that's the value we're going to use. The Book of Ohm. Yeah, this is the book of Uff and Puff and Nuff. That's how real engineers refer to the various values of capacitors. 0.1 makes all the difference. Well, it's too late. Where do you get a book like that? I got mine from Amazon. Jeff Bezos and his bald ass head dropped them off on my doorstep, and they were $40 from China. Well, there's just capacitors falling out of this. Yep, they were filled for $40, which is why instead of refilling some of the values and going through all the nonsense and ordering them, I have literally just ordered another one of the books. So 2 caps, they go all the way at the top here. God, my nails are terrible today. Remind the iron that I still exist. And we're back into it. Just like before, with my hands shakier than they've ever been for some reason today. This week, this month, this year. I guess I'm just getting old. Just getting old, getting a little shaky. I could probably use a tall wrist rest on this like I'm doing with the right hand. It would help a little bit. Hello? There we go. Doink. And then we don't have a lot of pad to work with. But it looks like it's enough, so that'll be good. Okay, so capacitors are just like leaking out. I've got them all over the place here. They dropped all over this board. Need a book like that? They're really good. They keep you nice and organized, and they give you plenty of parts, especially when you start to get into analog stuff. The analog stuff requires all kinds of different values of components because it's analog. It's all over the place. Digital's much more lenient. It's why I have bins that are filled with 100Ks and 10, not 100Ks, sorry, 10K and 1K. 10K and 1K will get you most of your current limiting needs in a digital circuit, and it'll also let you dim your LEDs so they're not blinding you, all that stuff. But when I started to do all of this synthesizer crap, it came down to needing weirdo values of components. And so I've had to bolster my collection. I hate it when it does that. You're not supposed to go on the iron solder. You are supposed to go on the pad. Like that. Let's grab one of these that I dumped down here. Bring it up. Okay. Ooh. We're going to flip this one and do the other side of it with my right and left hand properly positioned so that they go a little easier than the previous ones. Seem to be in a better groove with the placement using the iron for stability. Yeah, it's a lot easier. Just snapped my 0.5 millimeter wire at 0.05. Sorry, that's much less. Time to redo the trace repair. Trace repair that can be very, very annoying. I bought these kits that have trace repair stuff on them, and I haven't been able to actually use it because I haven't been able to get the tweezers under the thing. It should be this little adhesive patch that has a trace wire on it, but I'm just throwing capacitors out of this thing. What is going on? The plastic isn't adhered very well to the front, so caps are just falling out as it moves out of the way and jettisons these things. We might have some slightly weird pieces of the MULT, different frequency responses and stuff, because I can't identify the caps that are flying around. I could use the tweezers on them, the multimeter tweezers. Yeah, my right hand is not stabilized. That's why it's shaking all over the place. The iron is much more stable. Although I've lost all of my heat. I hate that. This is happening a lot. What'll happen is the solder will flow over the pad, and then it'll suck all the heat away from the pad and the iron. And so I'll be sitting there holding the bag when all is said and done, wondering why I'm unable to move the component at all anymore. Why is this moving in a weird way? Jeez, get a better grip. That's too much solder. All right, let's bring in this cap. This is a mystery cap. This one fell out of the thing when I was maneuvering it, but I don't want to waste these, so I'm just going to use it and see what happens. So if one of the channel's high frequency response is a little weird, we can chalk it up to that. Rando cap. Yeah, see, these are like standing up in the air. It's what's called tombstoning, which is where the capacitor attempts to create a tombstone, a gravestone, by the surface tension pulling it upwards. Because the entire end cap is solderable, and so the surface tension pulls evenly, and that ends up torquing it. Yeah, ground pads. Okay. Last cap. Oh, I didn't get that ground. Well, we would have caught that eventually. That's a chef's hat, by the way. That's a chef's hat. The folds representing the different ways you can cook eggs. How many ways can you cook eggs? Why is that not? It's like the worst. It's because I'm not. The stands are getting in the way. Oh, it's horrible. It's horrifying. Okay, hold on. Get it together. Get it together, bother. I want to at least finish soldering this thing today. We've got a little bit of time, but not a ton. Hopefully the dog is being taken care of by the other people in the household. They seem to never want to do anything to take care of the dog. Well, they don't want to go outside. it's like, it's the easiest thing in the world. You just walk around with the dog, and everybody goes, "Oh my God, is that a corgi?" Maybe it's the social aspect they don't like. All right, there's one jettisoned, and the other one is ready to fall out. But I can put these away because I don't need any more of these. I want to see a microscopic explosion. I don't do explosions on my stream. I hate to break it to you, but they're more detrimental to the streamer than you'd think. No, at the end of the day, I have all my fingers and toes. I plan to keep it that way by being good at what I do. Okay, there was a hair on the end of the soldering iron, and now I can smell it. Oh, God. Yeah, if you say Willow's name in chat, it'll pop up with a picture of her. Okay, this is the last cap that I need. Then we need to figure out what the LED circuit looks like. Because I have a weird LED circuit, and I think it came from that Reddit thread, but I do not want to log into Reddit on this machine, so I can't check what the values are. But let's flip it over and let's do all the cap soldering. Let's make sure our components are actually attached. That's kind of an important facet of this whole thing. You can be pretty lazy with the circuits on these things, but if I'm making boutique, bespoke synthesizer equipment for myself, I'm going to be using the good circuits. And so we've put in a good circuit on this thing. This is a high capacitance load operational amplifier circuit, so that if you plug in a lot of long cables to your MULT, it's, oh God, I hate it when that happens. It's not gonna cause any changes in the output voltages unintentionally. I think there's already solder on these. No, maybe not. Huh? Come on, there we go. Yeah, it was a bit of a random cap that just kind of fell out of the book. So, you know, the good stuff. That's this one right here, I believe. Maybe we'll never be able to find it again. I should probably, like, actually measure it. But, oh well. This one's super loose now. Must be working hard today. Here she is. She had a stressful morning. It's garbage day, so there was a lot of very loud noises. And my dog is, for some reason, very skittish. She did not come that way as a puppy. As a puppy, she was like the bravest dog in the world, too brave. We had a thunderstorm that was like really super loud when we got her, and she did not care. She doesn't care about thunderstorms. I don't know what the deal is there. Maybe the trainer went around with a big, or the breeder rather, whoever, her original folks, her old parents, went around with like a sheet pan making a bunch of noise to keep the puppies from getting scared. I don't know, but either way, it means that she does not care about thunderstorms. I really wish I could scooch these caps. With the components like this, sometimes you can heat them from the other end, and you can kind of nudge them into position. It seems like because of the angle of the microscope, and that's something that maybe I need to address in the future, the angle of the microscope made it so that these are pushed over to the side a little bit. Going through with hot air could kind of move them around. But they won't move unless I put copious flux on either end, so I might as well just live with it the way it is, unless I can actually get it to do anything right now. Nope. Okay. So we'll just leave it there. It looks like it's soldered. We'll just have to see if the circuit responds differently. Last one is right there. Positioning my clamps. Did we get that? It looks like we got it, but we didn't. It's very deceiving. Oh, I hear barking out there. An ad in 2 minutes. Jeez. I'm gonna have to run like a train of ads at the beginning of stream. Will bother be puzzled when it doesn't work. What do you mean? When it does work super duper well. Okay, we've got 6 more components to go into this, and they're the ones that are driving the LEDs. So what was I thinking when it came to the LED circuit? Eurorack op amp LED circuit. See, apparently this circuit will not give you a response when you drive it with your Eurorack voltages when it's like a unity gain kind of thing, because you have to get over the voltage that it takes to actually activate the LED. You have to get to 1.4 volts in order to get this to actually show you anything on the LED. So there's an alternative to that, and I think what they do is they have it. And so you've got a voltage divider on the input, and that's the circuit that I'm looking for. That's what I'm trying to emulate. Although I probably could just make, I could 100K, 100K. There, it's a voltage divider. But I think that's what I was looking for, because that's what I originally designed for. And I think that also came out of the Reddit thread that I can't get to because I don't want to log in. What did I do in Discord? Hold on, we got to do a little forensics here. That's what we ended up building for the amplifier. But then for the LED, I didn't show any values. Did I link anything? No. I think I talked about it earlier, though. If I keep scrolling up, I think I can find it again. Before we fixed Momo. No, digital filter simulator. Something, for some reason, a selfie. Cleaning of Momo. Curve trace DIY. Moog synthesizer fart tutorial. What have I been doing lately? No, it doesn't look like I have any discussions of it. Okay, so we gotta find it somehow. I actually might take this opportunity to break the stream and come back tomorrow. And we'll test it in the middle of the day when we've got more people and less ads running. Possibly. Oh, ad starts in 2 seconds. All right, we're gonna do an ad and then we'll figure this out. I know, I just don't have time. I gotta cook shrimp scampi tonight, so I have to get all of my after-stream chores done, which includes walking the dog. And then we've got modules to fix and everything. I got more work to do than you would ever believe, so I am tempted to do a marathon all the way through the weekend. I don't know. We'll see. Don't let chat get to you. No, I don't, but I give you guys the time of day, the benefit of the doubt. Yeah, I don't think I have anything pressing going on this weekend, but we'll take a look at that as time goes. I'm just looking here to see if I can find the eurorack circuit that I was going to emulate, and I think what it is that they put a voltage divider on it so that the voltages coming in are. Well, why would you do that? Wait a minute, you would want to double it and then no. Huh. That would compress it. There was a particular circuit that I was following that I liked. I think I have to go back to the source. I got to go back to that Reddit thread to see what was going on, because that's where all the good designs were. Wait a minute. Maybe the Emily Gillette one has, because it does. This looks similar, but it's a little bit different. We got 24.9K going to ground. We have our input signal going through a mega ohm. So what we have on this design, this is like design forensics. We're coming in through R11. We've got a resistor to ground. Deets! Hey, what's up, Deets? 81 months. Holy crap. That has been a time. You are one of the first subscribers to this channel. We're in the middle of an ad break. This is just what's happening now. I decided to enable mid-roll ads, and I was able to like make a couple things to, indicate that we're in the middle of an ad break, and a couple indicators for me about when I can start talking again. Did that trigger some type of hype thing? I think it just said hype. Thank you. I really appreciate that very much. So this is a simplified LED circuit, but this is supposedly one of the good ones that helps widen that gap, that voltage gap in the middle, supposedly. Unless I left something out, but I'm pretty sure that I just copied like this or similar. One going there, one to ground, and then an additional. I think this is it. I think it's this. That's why I had this one open. Just for this circuit right here. And that's it. It's an LM324. Wait a minute. What happens with LM324? Wait a minute. LM324 data chart. What does it say about thing that do? Oh, there's the click. And then I'm waiting for the green light to indicate. Oh my God. And now everybody's back from the ad. That's an 8-second timer on that one. So I'll be at school tomorrow. Dun, dun, dun. Hold on, I'm going to see what the LM324 is just in case it influences this design. Next generation. Drop-in replacements for all version of, okay. 3 to 36 volts. Low input offset. 2 kilovolt ESD, doesn't matter. Maximums we don't care about. Common mode input voltage, V input, all drivable to the supply voltage. This is rail-to-rail op amp, quadruple op amp. Why are we using an LM324? Maybe it was just cheap. The LM324B and 3, wait. What is it called? It's like Topic Industry or something. That's not the right one. That's not at all. Ah, I've got it open on the other computer, but my things aren't linked. So, but we played it before. What was it called again? Topical. Hold on. Deadlines. There we go. Oh, this is a Twitch exclusive joke. This should be on my soundboard, but the soundboard's all the way over there. The LM324B and LM2902B devices are the next generation versions of the industry standard operational amplifiers, or op-amps. LM324 and LM2902, which include 4 high-voltage 36-volt op-amps. These devices provide outstanding value for cost-sensitive applications, with features including low offset, common mode input range to ground, and high differential input voltage capability. The LM324B and LM2902B are unity gain stable and achieve a low offset voltage maximum of 3 millivolts, 2 millivolts for maximum, blah, 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 and quiescent current of 240 microamps per amplifier. Typical high ESD and integrated EMI and RF filters enable the LM324B and LM290B devices to be used in the most rugged, environmentally challenging applications. That should have been earlier, but whatever. Oh, look, it comes up. My own stream. Wait, what's going on? What's happening? All right, we can stop that. I love this trailer music. It's Deadline's trailer music. I wasn't able to get into like the good voice. I needed to like talk to the seats in the back when I do that. The LM3924. I can do a lot better than that, but whatever. That's the joke. Is when I'm reading a data sheet, I'm hearing this music in my head. The industry and activity topic trailer, Deadline's trailer music. And I'm not understanding anything that I'm reading. It's just a typical op-amp, and it's rail-to-rail, so there's nothing special about that op-amp being used in the Emily Gillette design. I had that giant hair has been in my mouth for like a half hour. Okay, LED design, we're using the Emily Gillette circuit. That's why I had it open. That's this right here. So we need 1.2, 83, and 1M. So 1M, 1.2, 83. And of course, being an Emily Gillette, it's all like mangled around. It's got kind of a weird arrangement here, but in the end, it is in fact the standard looking circuit. So let's get the 1Ms in. So if you guys didn't catch what I was doing there is finding out, hey, what's up? Wait, no, you're already Poopsie Doodle. How you doing? Finding out what the hell I was thinking when I designed the circuit, and then figuring out what values I was going to have on that specific thing. And it turns out I was inspired by this. Most of the time I'm copying Emily Gillette circuits because they're good. And this is just a rearrangement. This is sort of a more clear display of what is actually going on here. We've got 2 1 mega ohm resistors here on the inputs. So that's these 2 right here are having the signal, And then we've got a current limiting resistor down here, which is 1.2K. And I'll probably want it to be 2K just so it's not blasting your eyes out. Have you heard about the new generative AI training policy? Yeah, I've already rejected it. You guys should also too. You need to go behind your security settings to find it. These are going to be 1 mega ohm resistors. So these two, and then the two over here. You guys can't see them. Here and here. And so now we can see on our design which ones they is. And it's going to be those two and these two. Oh, off key a little bit there. Wait, what? Oh, this is the lower one, right? Everything's upside down. Everything is no longer upside down. We've reoriented ourselves. We are now topside. Okay, so these two are 1M. Oh, they admitted that it would be unwanted. They said if we didn't opt everyone in, nobody would opt in one of their live streams. I'm glad they're a little bit more transparent about it than, for instance, an Amazon would be. Hold on. Oh, that's great. Love that. Woo! That would be the effect of eating leftover meatloaf before stream. What could go wrong? What could go wrong? It's just a bunch of sugar and fat in a suspension of breadcrumbs. There's no, that would be that's the perfect food to eat before exerting your voice and stomach. Oh, there it goes. That one's gone. Yeah, and it's all the way at the bottom. It's like snuck in under there. Gotta be tricksy. Gotta be tricksy with these. God, AI is just getting freaking plugged into everything, isn't it? Oh, that is pain. I'm pretty done with AI. I'm not happy with it. And it's all the rollout. I mean, I'm happy for, you know, like industry usage and stuff, but having it plugged into literally everything, like as fast as it can be, is very concerning. If we can't put checks in place over this stuff, it's going to have pretty dire consequences. But it'll be just like that book, The Torment Nexus. I really want this to be in the proper place, but that's not really that big of a concern. Okay, I'll live with myself. We talking about? Wait, what's going on? 4 simple outputs. I'm not talking about complicated. Wait, what are we talking about? Oh, bother, have you ever come up with a way of submitting something like a small schematic diagram with some components and then change one of the values and ask for an analysis? No, I've never done anything like that. Why would I have done anything like that when I'm apparently a Luddite, according to AI people? No, I know how to do this stuff myself, so I do it myself. I gotta heat up this pad from the wrong side. That's not working. Let's just tilt it. Let's get tilted. I know they aren't polarized, but did you have to put it upside down? You gotta let go. You have to let go. You have to let go of that. You gotta let go. You're never gonna get anywhere if you don't let go. Give up. You can't bring the kids back. They're gone. Please. We need you here. All right, over here we go to the next bank, and that's all the way at the end here, so we gotta move our duck bill. Turn this a little bit. Yep. Ba-da-ba-ba-ba. It's constantly in my head. It's from that old meme that was like a car dealership ad, but the guy was like, you know, we'll fuck you over and all that stuff. Come down to Maryland's great auto mall. Oh, no, that's gone. Okay, those are the two 1Ms. I gotta go find them. Is there a site with a bunch of noob circuit challenges? Guys, that's called a textbook. They have them at libraries. You can go to a library and find a textbook, and it'll have challenges, circuit challenges. It's Circuits 101. Wait, could you just like ask an AI to make the snap circuits? Yeah, those do. I remember those. My nephew was absolutely spellbound when I was able to snap together something that was not in the book. It wasn't in the instructions, and it blinked an LED. He was like, "Oh my, what? How did you do that?" Libraries do not exist in my country. Oh, well, textbooks do. They're everywhere. They're everywhere. Look under like a bus driver's seat. Maybe they're using textbooks to prop themselves up, and there might be an electrical engineering book in there. Yeah, using AI for circuit analysis, no, dog. I know, not specifically dog. I meant to say dog just in general, but then I realized that I was talking to lawn dog, but I don't mean to specifically call out lawn dog. Anyway, screen names. No, like, oh man, circuit analysis is not difficult. You do the loops, right? And even though the stuff that you'll do in like a circuit analysis textbook is like really crazy and complicated, it's not that complicated in real life because nobody's designing crazy filters and stuff. So you get a feel for it, and maybe it helps to have somebody explain it a couple times like I have had. But man, like using a language model to do circuit analysis, no. That ain't it. That ain't it. That ain't it. What's a library? Where are these berries at? Are they tasty? Okay, so I need to find two 1 mega ohm resistors that have fallen. And one of them is here. And then we have the last two resistors are 2K. Oh, the other one hasn't fallen. It's right there. So this one needs to somehow... Okay, I think that got off with the tweezers. Now I want lychee. I can't control your cravings, chat. I can't. Am I going to get the iron in there? This needs to move. But if I remove that, the whole board falls. Wait a minute. Okay. There we go. Dun, 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 dun. All I need to do is get the AI to make a little podcast out of my kids' activities, and then maybe I'd actually be interested in hearing about them. The advent of AI has sort of highlighted how allergic to work some people are, and I don't know, some things take work. You got to do work. I don't have anything profound to say about it. We all know what this crap is like. I just think a lot of people need to get out of their delusions about it and own up to needing to do work to achieve things. I have been embroiled. I put these in two opposite ways for you guys too. I've been embroiled in working in circuits for a long time. So I've put in the hours to make this stuff. Sometimes when I ask AI some questions, I don't understand the feedback it gives, the language that it uses, and I'm not talking about English. It uses some kind of expression. Is it, were you breaking it? How deep are you into this? I think it's been kind of discouraging to see how susceptible to complete isolation people can be when given a friendly voice. This is so so frustrating. Using AI takes more effort than not. That's what I've kind of, I mean, I used early versions. That was like much earlier versions in order to try to do some microcontroller work, and it was downright frustrating. Now, Big John has described to me ways of using it where you have multiple AIs, and so you're just talking to an agent, and you say, I've given you connection to this Bluetooth. I need you to figure out how to control this light bulb. And it's able to do that, which I find fascinating. I think that would be very useful for our LIN-bus stuff, but effort on both the user and the computing resources. Yeah, apparently the resources are something to be concerned with. All of these resistors are completely crooked, and it drives me nuts, but there's really not much that I should do about it because they're all making good connection and they're relatively clean. So I'm gonna go to the 2K ohm resistors. So we're upping. You know what? I should probably put like a 5K in there, but I'm going to put 2K. It's still going to be a little bit bright considering the way that Emily Gillette does the circuits. I have to like meet this person, but I think they hate the modular synthesizer community. I think they were driven to leaving all of their files open for everyone to use, but I have an infinite amount of appreciation of the effort to allow me to educate myself on the level that I have by not having just baby material or closed circuit professional stuff. This is like open professional designs that I can learn from. It's been like the absolute best resource for me, somebody who already knows electrical engineering, to get to where I've been able to get to with modular synthesizers. Why am I unable to put any heat? Oh, because it's a ground pad. Okay, yeah, that makes sense. But I've got good heat relief on these, and I'm using my big high-powered iron, so I guess maybe there's just enough heat for it to kind of like create a heat sink and really bleed away all of my heat momentum. I don't know what else to call it. Heat inertia. The latent heat stored within the iron. Stored within the iron. I don't have a good voice today. I threw up this morning. I woke up, felt good for once, took a shower, took all my pills, but I didn't have a bunch of glasses of water like I normally do, and I think all of my pills gave me like pill tummy, and so I was talking to my dad for a little bit, and I just coughed, and I'm like, oh no, here we go. And it was that cough was the harbinger of my eventual toilet time. Just like it was like an allergy cough. I had like a bit of a dry throat, and then it was just, yeah, inevitable. And so yeah, that's why I've been unable to do the presenter voice that I would normally be able to use. Get those dulcet mid-tones, my natural baritone. 30B. I hate these. I really dislike resistors with codes. They should just wear their heart on their sleeve. I hate it when it does this. Stop it. These are of course problems that Flux solves handily. So holding that down, doing this. Thermal energy is just like kinetic energy at the atomic level, so inertia works. Huh. Entropic inertia. Look at that. Beautiful. There's my iron. Where's the solder? There it is. Okay. Come on. Come on. Do it. Do it. Come on. Do it. Do it. Do it. Oh, it's too much. It's fine. I'm not gonna penalize that. That seems okay. All right, so We are all soldered except for the blah, 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 blah. The sockets. We got to do the sockets next. That's the last thing that I have to do. But before I do the sockets, I guess I could power it up just to satisfy you guys to see if it blows up or not. I don't think it will. I think it'll work perfectly fine. There's really not much to the circuit. We don't, so like the inputs come in here and here. So I don't, you know what I'm going to do? I'm going to wait for tomorrow. We're going to do the part 2 on this thing because we still have to do analysis of this when we put it together and it works or doesn't. So my thoughts are that I should be paid for my time, and I'm not consulting you right now. What are you asking? Another nobody does it idea. Let's say you have a schematic and you use software to take that schematic and redraw it into a new circuit board, not something that is a copy of the original, just reorganized because I took the schematic diagrams, changed where the components are, and it's not an exact copy. I'm not a lawyer. I am not a lawyer. I am not a lawyer. I'm not a lawyer. I'm not a lawyer. I am not a lawyer. I'm not a lawyer. I'm not a lawyer. I am not a lawyer. Submit a board that you've converted the schematic diagram by hand and submitted to the PCB way, like the circuit board I worked on. I'm not a lawyer. I did not study engineering law. I know how to build circuits. Computer part prices have blasted off to YouTube, yeah, or to Pluto. Yeah, I posted something in the funny section, which is just like, you guys, you can put the funny section of the Discord on mute. We don't mind. But I posted something in there that was ChatGPT checking over somebody's computer build, and they were going, hold on, that RAM price, there's something wrong with the RAM prices. It shouldn't be that high. And this is like ChatGPT saying this. It's like, you did it. You're the reason. Yeah, I've said it so adamantly and often that it has looped the dial, and we are back to being a lawyer. Is that like a, that's like a speedrun tactic for passing the bar, right? You back yourself into a corner and you say, I'm not a lawyer 600 times. And then when you get up, when you stand up, there's not enough room, and you go, and you fly about 600 miles to the left, and you have your bar exam passed. It like pops up at the bottom of the screen. Badunk, you've passed the bar. You can now give legal advice. I'm pretty sure you're a lawyer. Is this legal advice? Yes, and I'm also a doctor. I'm a medical doctor. ChatGPT's data is several years behind. Yeah, so it'd be like looking up years old. Well, it's not that it's looking up years old stuff, because it's heuristics and probabilities and neural network stuff. But at the time, the heuristics and probabilities and neural network stuff pointed to lower prices on PC hardware as being the norm. So AI goes, it's eerie, but you're absolutely right, except that the prices are weird. Yeah, and it also just makes things up because it's heuristics and probabilities, and it's not thinking. It doesn't think. It doesn't do research. It uses statistics of its time to make sentences that sound like somebody or human language would put forth. Right? It's nothing more. Did I actually center these things? No, maybe a little. Yeah, kinda. Not really, though. But I don't think there was any chance that we could have had those pins sticking through. Would have been nice. You know, if I used more chips, but that would have strained the design a little bit more, is if I had two TL072s instead of the TL074, that could sit in the middle of this just fine without me having to get into layer shenanigans and having to clip pins so that they didn't interfere with stuff. But regardless, you know, J9, our power plug, that never would have fit. So people who don't know now feel like they do. Well, yeah, I mean, a friend of mine early on, basically just parroting like Joe Rogan talking points, said, you know, dumb people will get smarter and smart people won't be burdened with dumb people. And like, that's a super reductive view of what this all is. But I don't know, man. I don't feel like interacting with AI. I never consented to this. Go away. Just go away. Leave me alone. I'm going to be a Luddite and build my own synthesizer, and then I don't have to think about learning language models and what it can do to my chef's hat. You know? I don't give a shit. I don't want to deal with this shit. Did you know you could be more capable? Dog, I'm already the best that I've ever been. Like, I don't need to go hard into the paint. And I don't mean lawn dog. I keep saying dog is like just a way to talk to my straw man. And it's not lawn dog. I'm not specifically referencing a single user. I'm just saying dog because I'm from Philly. We're going to finish this thing tomorrow. I'm not going to push myself to finish it just because I need to make shrimp scampi tonight. And it's not an AI recipe. It's a recipe that I got going up here. I'm going to make some shrimps. I'm going to add some butter. Then I'm going to add some pasta water. And I'm going to throw it. And it's done. And it'll be good. So I'm going to go make dinner eventually. I mean, in a little bit. I got to walk the dog first. But it's getting a little late. Stream usually goes till 5:30. I would like to push myself in the near future and go longer because we got a lot of people here today. And there were a lot of great chatters. You guys have been awesome. I really appreciate the chat moving while I'm doing this. Be careful of pasta. I have had diabetes longer than most of the viewers here have been alive. I have had diabetes for over 30 years. I know what I'm doing, man. I can do pasta. Where are we right now? What's my post meatloaf? Yeah, we're doing great, man. This AAPS, like, holy shit. Like, raid the Sparks Maker guy. I probably should at some point, yeah. I want to see if any of I'm near 40 years old. Oh, 40 years of diabetes. Nice. Very good. Yeah, Wilford Brimley made diabetes look like the common cold. Same with the rest of us. We're doing great. The technology, it's come a long way. And the people who care do really good. So flying, oh man. My teenage years were terrible. I really needed to give more insulin than I did. Do we raid someone? We don't raid people very often because I have like raid paralysis. Maybe it goes along with executive dysfunction of ADHD. I have like raid paralysis where I don't know where to send you guys. I've been meaning to send you guys to like Doug at some point when he's doing like smart programming stuff, but he hasn't been doing that at the course in parallel with us. Sput is playing approximately up, and that game looks pretty fun for somebody who knows control systems, but it would be tantamount to torture if I sent you there, because those of us that know control systems would be looking at what they're doing and going, oh no. So Paleontologizing is another Knowledge Fellowship streamer, and he's got like 300 people watching. He has to be doing something right? What is he doing? Exposing more dinosaur auction scams. That sounds actually fascinating. One of these days, we need to do a paleontologizing raid. Sir Lar is Lawrence from Funhouse, Inside Gaming, etc. I love those guys. Should throw you guys at Lawrence at some point. Although he doesn't, I don't know if he knows I exist. Davies is a small streamer that does a lot of My Summer Car. I love his content, and he's a nice chill streamer to kind of meet the mood of today, which was to stay kind of, Sid Heresy. That's where we should actually go this time. Did we raid Sid before? Let's just raid. Yeah, if I can get the name right. That's Sid Heresy. I've been meaning to raid, but he's soldering Euro. Are they? Is he actually live right now? Raid Sid Heresy. Yeah, it even capitalized it for me. That's kind of nice. All right, so the Twitchers, all of my Twitch audience, the nerds, we are going to raid Sid Heresy. They also build eurorack stuff. I don't mean to professionally build eurorack stuff. I just haven't gotten around to other projects. I'm going to do the end card, which contains the link to the Discord. My blue sky is dead. We'll figure that out at some point. But approximately this time ago, I'm going live tomorrow at the same time, so you'll see me tomorrow in about 23 hours or something. No, not 23. It's like 20 hours. 20 hours from now, I'll be live again on Twitch, and we're gonna finish up the MULT. It always takes a while to do even the simplest stuff on stream. We had to look up a lot of these values. If I was actually a good engineer, I would know what they are, but I don't. So let's go ahead and raid Sid Heresy. 20 hours, I'm back here. We get the thing running, we power it up. Everything works the first time, and we have no problems at all whatsoever. I'll see you guys tomorrow. Why are you still here? Why are you still, who told you that you could use weird plugins to not participate in the raid? That is illegal. I'm calling the police. Where's the